In this section of the course, we're going to look at another way of communicating between microservices. And it's important to note this is not between, for example, the user who's using a web browser and the broker. We're going to use JSON for that because that's the most widely accepted and functional way of doing things between a browser and some service. We're talking about connections between microservices. So far, in the vast majority of cases, we're actually posting JSON between microservices. So, for example, somebody hits the broker and says, authenticate. And the broker accepts a JSON request, unmarshals it, looks at what it has to do, sends another JSON request off to the authentication microservice, which then unmarshals the JSON and does something with it. And then the authentication service sends back JSON to the broker, which then sends JSON back to the user. And that works really well. In a lot of cases, that's all you really need. We also, of course, have a means of logging using the queue. So when we log something right now with our front end, the user sends JSON off to the broker, which unmarshals the JSON, and then pushes it into the RabbitMQ, into the queue. And then the listener gets pushed a payload from the RabbitMQ and does something with it and logs it. And that works really well as well. Now in this section, we're going to look at something called remote procedure calls, RPC. And one thing that's really important to know about this is that in Go, if you're going to use RPC, it has to be Go applications running on both ends. So I have a Go application running in my broker, and I have a Go application running in my logger. And what we're going to do in this section of the course is implement RPC between the broker and the logger. Now this won't work if the broker is written in Go and the logger is written, say, in Python or Java or something that's not Go. You have to have Go on both ends. And that's not a big deal in our case, and it's relatively easy to implement. And it can be much faster than marshalling and unmarshalling JSON, which is why you would use RPC in the first case. Okay, so let's get started. Okay, so our goal this time around is to implement RPC, and we're going to do it just with the logger service, because once you've done it in one service, it's trivial to duplicate that functionality for other services. And fortunately for us, Go makes it remarkably simple to enable RPC. So I'm going to go over here to my logger service, and inside the CMD folder and the API folder, I'm going to create a new file. And that new file is going to be called, not surprisingly, rpc.go. Okay? And of course, this is in package main. And what we're going to do to start with is set up a type. And anytime you want to implement an RPC server, you do need a specific type for that. And it doesn't have to have any particular, magic about it. You just declare a type, and I'll call it RPC server. And it's a struct, and it has no members at all. Okay? We're also going to want to define the kind of payload that we're going to receive from RPC. So in this case, I'll declare a new type, and I'll call it RPC payload. And it's a struct. And for us, right now, it only has two members, name, which is a string, and data, which is also a string. Okay? So now we have the RPC server type, we have the payload type, and now we just write methods that we want to expose via RPC with the receiver RPC server. So we'll have one here. We'll call it declare function. And I'll call it, or it has the receiver R, type pointer to RPC server. And here's something I'm going to expose using RPC. And I'll call it log info. And it's going to take one payload, one parameter called payload, of type RPC payload. And it also has a second parameter called RESP. That's my name. I'm going to call it whatever I want. And it's always going to be a pointer to a string. And this is what we're going to send our response back as, okay? And this potentially returns an error. So there's my function. Now, what am I going to do in here? Well, what I want this function to do, of course, is to write to the log. And that means I'm going to be writing to Mongo. So let's get a collection. We already know how to do this. A collection in this case is going to be assigned the value of client, which is a package level variable, .database, and it's going to write to logs to the collection named logs. So we have our collection. Now I'll ignore the return value, but I'll look for an error when I call collection.insert1. Okay? And of course, this requires some kind of context, and I'll just use the context.todo. That'll do the trick. And I'm going to define a data type, or type from the data package called log entry. And in curly brackets, I specify it has a name. And in our case, the name is going to be right from payload, which we received as a call to this function, .name. It also has to have some data. And of course, that's just payload.data. And it also requires a created at. Created at, and I'll just make that time.now. Okay? So we check for an error. If the error is not equal to nil, then I'll print out the error. So I'll just say log.println. Error writing to Mongo plus the error. And I'll return the error. Otherwise, here's where we need to send our message back. So we have that parameter, resp, and I'm going to go pointer to resp is now equal to processed payload via RPC. And then I'll put in the payload name. So I'll do it like this, plus payload.name, just to give us some feedback. And I'll return nil. So just to go through this again. First thing we do is we declare a type that's going to be the RPC server. Then we declare a type that's the kind of data we're going to receive for any methods that are tied to RPC server. Then we declare, well, in our case, one function that has the receiver pointer to RPC server, and that requires a payload of some sort. And then resp is a pointer to a string, so we can send a message back to the people who call us. And that's all there is to it. So we process our data, and we send the response back by setting the pointer to RESP, the variable we have right up here. We give some kind of feedback there. And that's all there is to it. Okay, so we've defined this. Of course, the next step is to be able to listen for RPC connections. So we're going to have to make some more changes to our logger service. And we'll get started with that in the next lecture. So now we have an RPC server defined, and we have a type to receive a payload, and of course we have one method, loginfo, that's available to people who want to call the RPC server. But of course we need to actually start this server, and we're going to do that back in the logger service in the CMD API folder in the file main.go. And if you'll recall, when we defined some constants here at the top of this file, we defined a constant RPC port that says port 5001. So let's go down in our code, and we have this commented out function serve, which was a mistake I made some time ago. I'm going to delete that, okay? And instead, I'm going to create a new function with the receiver of app, pointer to config, and I'm going to call this one RPC listen. And inside that function, first of all, I'll print something to the console, log.println. Starting RPC server on port, and then I'll just put a space there. RPC port, okay? Just so we know it's going to start up. Now, how do we listen on RPC? Actually, it's absolutely trivial. What we do is we declare a variable listen while checking for an error, and those are populated when I call right from the standard library, net.listen, right there. And what are we listening for? Well, we're listening for TCP connections, so TCP as a string. And then where do we want to listen? And I'm going to use format.sprintf to build a string. And the string I'm going to build is listen on all IP addresses 0.0.0.0 colon, and then a placeholder, which is a string. And my substitution for that is just RPC port. Okay? So that creates a variable called listen. But of course we want to check for an error. So we'll say if error is not equal to nil, then actually I'll return an error with this. And here we'll just return the error. Okay, so we're listening. Now let's defer listen.close so we don't have a resource leak. And now we just have a loop that executes forever. And all we do in here is we say RPC con, which is a variable name I'm declaring, and potentially an error, come from listen.accept. So we accept connections. And we'll say if error is not equal to nil. In this case, I want to continue. Just want to start over. Okay? And down here, we say go RPC dot serve con. We run that in the background. And we serve it with the connection RPC con. So there is a function that will start up our RPC server. And of course, we need to call it now. So back up here, I'm going to delete this comment because we're not using that at all. And right here, before I start the web server, I'll just run go RPC listen, app.rpc listen. So there is one more step, and then we should be done with this part of the code. And right here, just before I call go app RPC listen, that will actually execute without any problems, but nothing will work because we have to register the RPC server. In other words, to tell the application that we are going to be accepting RPC requests. And fortunately, that's a one-liner. All we do is check for an error when we call from the RPC package, which is part of the standard library, .register. And we register a new and give it the type, RPC server, right there. Okay? And that should be all that's required. So if everything goes according to plan, this will now accept RPC requests. And of course, we still have some work to do. We have to go over to the broker, for example, and modify that code to send an RPC request. But that's not terribly difficult, and we'll get started on that shortly. So now that we have our RPC server all set up in our Logger microservice, we need to make some changes to the broker in order to be able to call that server. So over in the broker service in CMD API, let's open up the handlers.go file. And we'll do something very similar to what we did in the last section. We're going to change this call in the switch statement in the handle submission handler. We'll change it to call a different function, one that logs via RPC. So again, I'll leave the log event via rabbit here as a reference. So you'll have two unused functions, log item and the one that logs via rabbit. So let's go down to the very bottom of this file. And I'll create a new function. And it's very simple. A function with the receiver of app pointer to config. And I'll call this one, let's call it log item via RPC. And it's going to take the same two parameters that the other ones do, a response writer, and it will also take a log payload, L log payload. And it doesn't return anything. So let's give ourselves some room and get started. So what we have to do to start with is to get an RPC client. And again, Go makes that remarkably easy. So I'll declare a variable called client, and I'll check for an error when I call from the standard library RPC dot dial. And I'm going to dial using TCP to, and I specify in here the name of the microservice from my Docker Compose YML, which is called logger-service, and then the port we're listening on is 5001. So I create that client. And of course I check for an error. If error is not equal to nil, in this case, I'll just write out some error JSON, app.error.json, with W and the error, and I'll return, because I can't go any further. Okay? But if I have that client, now I need to create some kind of payload. And here's the thing you really need to be careful about. you need to create a type that exactly matches the one that the remote RPC server expects to get. Now we're only going to do this in one function, but typically you might be doing it in multiple functions. So let's create the type outside of this function, and I'll call it RPC payload, exactly the same name I used in the server end. It's a struct, and it has two fields, name, which is a string, and data, which is a string. Okay, so now I have a type. So let's create a variable of that type down here in our log item via RPC function. So I'll create a variable called RPC payload, and it's of type RPC payload. Try that again, RPC payload, and I'll populate its fields. So in this case, name is going to be equal to l.name, and data is going to be equal to l.data. Okay? So now I have my data, my payload I'm going to push, and I'm going to get some kind of result back. So I'm going to declare a variable, result, and this is a string, and that's going to be populated by the remote RPC call. Okay? So I have a place to store my result. Let's scroll up a bit. And now I just check for an error when I call client.call. And here I tell it exactly what I want to call. And it's going to be RPC server, which is the type that's created on the server end, and then a dot, and then the name of the function I want to call. In our case, it's called log info. And of course, that means that any method I want to expose to RPC on the server end must be exported. In other words, it has to start with a capital letter, or it's just not going to work. So that's the first of three parameters. The second parameter I'm going to pass it is my data, which I just created. It's called RPC payload. And the last thing, of course, is the response from the server. And that's a reference to the variable I just created called result. So I check for an error, so I can just copy this error code right here and paste it right here. And finally, I can actually write some JSON back to the end user. Okay, so if everything went well, if I got past this, then I'm all set to give my response. So I'll declare a variable payload of type JSON response, and I'll populate its fields. Error is false, and message is result. And I just write that JSON out. So app.writeJSON, and I hand it w http.statusAccepted and payload. So now that this exists, I can copy this function name, go back up to that switch statement, wherever it is, right here, and instead of logging via rabbit, I can now paste in the new function name and log via RPC. And that should be it if we get everything right. So in the next lecture, we'll build everything and give it a try. Okay, if we have everything done correctly, we should be able to bring this up now and actually go to the front end and click the log button, and it should log everything using RPC. So let's open our terminal window and make sure we're inside the project folder. I am, and I'll type make up_build to build everything and bring up our Docker images. Everything built, that's a good sign. So now it's building the Docker images. And it's bringing them up. So far, so good. And of course, I need to wait for RabbitMQ to start, but I can at least clear the screen and type make start to bring up the front end. And it's running. So let's go back to our web browser. And I see I have it open already, so let's reload the page. Okay, it's current. And now before I go any further, I'm going to go down to Startup MongoDB Compass. And I'll go and look and see what we have in that logs collection. So I'll click on my recent connections and connect. And inside databases, that tab, I'll go down to the logs collection and look at the documents. And we have 2 entries right now. Perfect. So let's make sure that RabbitMQ is started up. So we'll go to Docker Dashboard and go to the project and find the broker service. And there, it's ready. So at this point, I should be able to click test log and hopefully we'll get the correct response back. So, processed payload via RPC event. Let's go make sure it actually logged. I am not an optimist. So back in MongoDB Compass, I'll refresh this collection. And there it is. It logged it for us. So everything works exactly as expected. So now we have another means of communicating between microservices, RPC. And as you recall, you have to have Go on both the client and the server. That has to be the programming language used to develop both the client and the server. But it actually works really well. And it actually is considerably faster than processing JSON payloads. So it's an alternative method of communicating between microservices. Let's move on and look at a third way of communicating between microservices, and that's gRPC. And it's a little more complex, but it's more portable. You can actually have services written in whatever language you want, pretty much. It has all the major languages using gRPC. So you're not limited to working just with Go. So we'll explore that in the next section. So now we have a number of ways of communicating between microservices. We can use JSON post, and our microservice receives the JSON post, does something with it, creates another JSON response, and sends it back. We can also use RPC, or remote procedure call. And as you'll recall, that presupposes that the application that is acting as the client is written in Go, and the application acting as the server is written in Go. And we did that in the last section. We can also push something onto a queue, an AMQP, Advanced Messaging Queue Protocol, like RabbitMQ, and have a listener receive events from that queue and then do something with them. And we've done all of these things. And in this section of the course, we're going to move on to another means of communicating between microservices, and that is gRPC. And nobody's really sure what the G stands for. It was actually initially developed by Google, used internally for about a decade, and then open source some time ago. So it might stand for Google, but there's a fair bit of contention about that, and it doesn't matter. The big difference between gRPC and RPC, there's a number of differences, but one of the most significant ones is that you don't have to have both ends, the client and the server, written in Go. gRPC actually supports Java and Kotlin and PHP and all kinds of languages. So we're going to do both of them in Go because this is a course about working in microservices with Go. But just bear in mind, if you want to, it's pretty easy to actually write one of the ends in a different language. And gRPC actually makes that really easy by using something called a proto file. In any case, what we're going to do in this section of the course is to rewrite the bit of code in the broker and the bit of code in the logger that deal with RPC, and we'll add functionality to support gRPC. Now, it is a bit more work to do this, and in some cases, you'll actually wind up with faster code, but there have been projects like the min.io file server, which actually rewrote their RPC code into gRPC, and things slowed down. So it would be unfair of me or inaccurate of me to suggest that it's always going to be faster if you write it in gRPC, but in many cases it is. And of course it depends entirely upon your use case. In any case, let's get started. Now, in order to work with gRPC, we need to install some additional tools. And there's two things we need to install. And they're relatively easy to install, so let's get started. Now what these tools do actually is when we're writing code that uses gRPC, these tools actually generate some code for us. We write something called a proto file, and then we run a command that will execute these two tools. And that generates some code for us. And the great thing about this is I can share that proto file with another developer working, say, in Java, and that person can type the appropriate command in their Java development environment, and it will generate the necessary Java code. So it saves us some time. So let's install them. And the first one is installed like this: go install google.golang.org/protobuff/cmd/protoc-gen-go at, and make sure you use this version. Later versions would probably work until we have a major upgrade, but just to make sure that things work exactly the same for you as they do for me, use v1.27 and hit return. And I already have this installed, so you'll probably have to wait a little bit longer. But that takes care of the first tool. Now the second tool is installed the same way. Go install from google.com or .golang.org/ but this time it's grpc/cmd/proto-c-gen-go for go -gRPC at, and again use this version, v1.2. And that will go and get that for me. So here it comes. Now they're all installed. Okay, so the process we're going to follow is pretty straightforward. And it goes like this. First of all, we define a protocol. In other words, we write something called a .proto file. Okay? Then we use the two tools we just installed to compile it. And that's one command at the command line. And after that's done, we have some code to work with. Then we go write our client code, and then we go back to wherever the server is, and we write our server code. And finally, we run everything and test it. So it's exactly the same process no matter what you're doing. Define the protocol, compile your code, write the client code, write the server code, and then test things out. And that's exactly what we're going to be doing for the remainder of this section. So let's get started. So we have the necessary tools installed, and now we need to generate a protocol file. And of course, this file is used by those tools to determine what kind of source code it should produce for us. So to get started, I'm going to go to the logger service folder, and at the top level, right beside the CMD folder, I'll create a new folder, and I'm going to call this logs. Okay? And inside of the logs file, I'm going to create a new file, which I'll call logs.proto, proto, for protocol, okay? And I'm going to ignore this right now. And there's probably some plugin that will give me syntax highlighting, but this is a dead simple file, so I'm not concerned with that right now. Now, this file is going to be used to tell those tools what kind of source code to generate. And first of all, we declare what syntax are we going to use. And that's going to be equal to proto3. Protocol 3, semicolon. And if you've been writing Go code, as you have been for this entire course, you're not used to that semicolon, but we actually need it here. We're not writing Go code. Next, declare what the package is going to be called. What are we going to call this? Package will be called logs, okay? With a semicolon. And next, we're going to specify some options. Now there's other options we're going to specify from the command line, but I'm going to specify one here. Option, space, go_package, which is a reserved word in the protocol syntax, that's equal to, in quotes, /logs, okay? Semicolon. And then we describe the kinds of information that will be passed around. The first one is a message, okay? And it's going to be called log, and it looks like you're defining a struct, but you're not. This kind of data is going to consist of a string with the name, and if that's at position 1, okay? Semicolon. The second thing we're going to be passing, string, is data. And this should look familiar to you because this is the kind of information we're passing every time we send something to the logger microservice. And that's at position 2, so I'll put position 2 and then a semicolon. And then after that, I'm going to declare another kind of message. And this is what's being passed around. This one's going to be called log request. And again, it has curly brackets. And it's going to have one entry, log, called log entry. And that's at position 1. Okay? We're just describing the data that's being passed around. And the third and final message is going to be called log response. So obviously, log request is the request to perform a log operation. And log response is what we send back. And that has one field, string. I'm going to call it result. And it's at position 1. Okay? The last thing we need to do in this protocol file is to actually define the services. Okay? So service. And it's called log service. And it has an RPC. It's a remote procedure call, which I have to spell right. And here I just define the name of the function that this gRPC system is going to have. And we only have one function we're worried about right now. I'm going to call it writeLog. And it's going to take a log request. And it's going to return, so returns a log response. And that's it. That's dead simple. So just to go over this again, you describe the kinds of message you're sending around. So we have a log request, and a log response. And then you define the service itself, RPC, it's a remote procedure call. We're going to have a function called writeLog, and we're going to write that actual function soon. It takes a log request, and it returns a log response. And everything else is just pro forma. What syntax, what's the package going to be called, and what's the Go package called. So, dead simple syntax. Now in the next lecture, we'll actually generate some code with this protocol file. All right, let's move on. So between the last lecture and this lecture, I actually installed an extension to Visual Studio Code that gives me a bit of syntax highlighting for .proto files. And it's this one right here, protobuf support. So if you want to install that just to have a little bit of highlighting, you feel free to do so. So now that we have this .proto file for our logs service that's going to be running through gRPC, it's time to compile this .proto file into some source code. And to make that happen, we're going to be doing it from the command line. So I'll open my terminal. I need to be in the directory called logs inside the logger service. In other words, the directory that has this .proto file. And there's one more thing I'm going to install just to make my life easier. And it's a little binary application called proto-C. So in the course resources for this lecture, you'll find a link to this web page. Protocol Buffer Compiler Installation, found on grpc.io. And it gives you a couple of options here. If you're on Linux, for example, you can follow these instructions here. If you're on Mac and you have Homebrew installed, you can type brew install protobuf, and that'll work just fine, okay? Or you can install a precompiled binary for any operating system. And it tells you to manually download from this link the zip file corresponding to your operating system. So let's go look at that link, which I have open in another tab. And I'm not going to use the release candidate one at the top here. Instead, I'll use this one. And I'll just scroll down to the assets bit, and I'll find the one for my operating system. Now, I'm not going to be using the one for all. That's just too much stuff. I don't care about C# or C++ or Java. I'm going to go way down here to the Mac OS for x86-64. And of course, if you're on an Apple Silicon, you'll want this one. And if you're on Windows, you'll want the 64-bit one, almost certainly. So I'm going to download this one, which I've already done. Then I'll go over to my Finder, and I have the zip file already extracted. And inside of that, there's a bin folder, and that's the file I want. And I want to put that somewhere that's available in my path, so I can just type proto-C. So I'll go to my favorite terminal program, and I'll make sure I'm in the desktop. So I'll go to my home folder, and then the desktop, and I put this in a folder called proto-C. And inside of that, I have a folder called proto-C right there, that long name. Then I'll go into the bin directory, and that's where the executable is. So I'll copy that to my home directory, then to the Go folder, then to bin. And that's probably where you want to put it, because that's almost certainly, regardless of your operating system, where your Go binaries are installed. So I will hit return, try that again, type it right, cp proto-C to my home folder, to Go, to bin. Okay, so it's in there now. Now if I actually try to type which proto-C, it should show up, and I found it. But if I try to execute it, if I say proto-C -- version, my operating system says, I can't open this because the developer can't be verified. So that's no problem. I'm just going to go to my system preferences, and I'll find security and privacy, and this is Mac specific, I think. And I will say, under general, it says proto-C was blocked from use because it is not from an identified developer, so we'll allow anyway. And that should take care of it. Let's go back here and type proto-C version. Oh, try that one more time. I have to unlock this first. And now I'll say allow anyway. There, that should do it. Go back here, and try running proto-C version. And we'll open it, and it gives me the version. So now if I run it this time, no warnings. Okay, so now it's available to me. So just some extra steps, a bit irritating, but we only have to do it once. So back to my IDE. And at this point, we're ready to run the necessary command. Now, I don't want to mistype this, so I've copied it to my clipboard. I'm going to paste it in here, and then we'll go through it. Okay? So here's the command. You start with the command proto-C, and this has to be run right beside the .proto file, so inside that logs directory at the root of the logger service. Proto-C, then --go_out equals dot. We're going to put everything into the current directory. That's what dot means. Then go_opt equals paths equals source relative. That tells it where to put the necessary source code. Then we do the gRPC out here to the current directory, and then the same sort of thing, we specify the paths, and finally we say do all of this using logs.proto. So when I hit return, it should generate some source code for me. And if I go back now to my Explorer, I have two new files, logs_grpc.pb.go and logs.pb.go. And those are two files I'm never going to have to edit, okay? They're automatically generated. So if I open this one up, for example, it's telling me, well, you're going to be using all of these things, proto-reflect, proto-implementation, all of these things. And some of these aren't installed. And let's not worry about that too much. If necessary, we'll go and get those packages. The point is, at this point, it's written a lot of source code for me. And the nice thing about this is if I ran that logs.proto through the appropriate command for Java, it would produce Java code. For Ruby, it would produce Ruby code. Okay, so we're getting closer. We still have some work to do, but let's move on in the next lecture. Okay, so we've generated some source code, but it's not doing anything yet. Over here in our logs.proto file at the bottom, we specified that we're going to have a function called writeLog, and that's going to be a service available to gRPC for this particular application. So what we need to do, we've exposed the service here, and we can expose as many functions as we want. We just have to go write them, okay? So what I'm going to do is I'm going to go over to my CMD API folder in the logger service, and I'm going to create a new file in there called grpc.go. And that's where I'm going to put everything here. Of course, this is package main. Now, let's go back down to our terminal for a minute, and I'm going to make sure I'm in the logger service folder. And we'll go and get some of the code or some packages we're going to need. The first thing we're going to have to go get is google.golang.org/grpc. And that will go and get it for me, all the necessary packages, okay? And then I'm going to hit the up arrow and backspace over gRPC and get protobuf, which might have been installed by the last command, but I just like to make sure. So it did upgrade it for me, which is good. So now I have the necessary packages. And you'll notice that when I did that, the errors that were in logs gRPC, their generated source code, those two files, those went away, okay? So let's start writing our necessary code, at least some of it in this lecture, to actually have a function called writeLog that will allow me to communicate over gRPC. And of course, this is going to be the server. This is what's going to receive requests. So the first thing I'll do is I'll hit return a couple of times, and I'll create a type called log server with a capital S, like that. And it's just a struct, and it has two fields. And the first one's going to seem really weird. It's just logs dot, and we're going to go unimplemented log service server, right there, okay? Now this is going to be required. This type, or this member of your struct, is going to be required for pretty much every service you ever write over gRPC. And basically it's to ensure backwards compatibility. Okay, so that's there. We just have to have that. We're also going to have a model called models, data.models. And that's so we have access to the necessary methods to write to Mongo. Okay, so no surprises there. So that's the first thing I'm going to have. And it's doing some imports for me, which is good. Now, I'll write my function with the receiver of L, pointer to log server, okay? And this is our write log, the one that we have to have. And it requires a couple of parameters. First of all, it has to have a context, CTX. That's what I'm going to call it, of type context.context. Okay, context. And it did the import for me, good. So it has to have that. And it's also going to have a request, REQ is what I'm going to call it, and it's a pointer to, from the logs package, that generated code, .log request. Right there, okay? So that we're using generated code now. And it's going to return, it receives a request, it's going to return a pointer to logs. No surprises here, we're getting a request, so we're sending back a log response and potentially an error. Now, here's where we continue using some of the generated code. I'm going to get some kind of input to this function, and that's assign the value of REQ, which is the logs request. Right there is our second parameter in the call to this function. It has generated for me a nice function named getLogEntry that gets my input, okay? And I can, just if I want to, I could put a log print line to look what it is, but it's just input.name and input.data. And we know that because we specified that over here in logs proto. We have name and data, okay? So back to our gRPC file. We have our input. Now we want to simply write the log. That's what we're going to do. So we'll create a log entry. That's my variable name. It's of type data.logEntry, and I populate its fields. Name is input.name, and data is input.data. Okay, so now I have something to write to the log. Now I just use the models field that's part of the log server, and I write to Mongo. So I'll check for an error, and this is absolutely the same as we've done everywhere else. L.models.logEntry.insert, and I'm going to insert log entry. And I check for an error. If error is not equal to nil, then I'll say, here I'm going to make a response, res for response. That's equal to a reference to logs.logResponse, right there. And I'll put in result, which is its one field. I'll just put failed. Okay? Whatever. And here, I'll return res and the error. So something went wrong. Let's hope that doesn't happen. But if nothing went wrong, then all I have to do at this point is return, try to spell that right, return a response. So res in this case is assigned the value of, once again, a reference to logs.logResponse, and I populate its field with result logged. Okay? And I return res and nil for the error. So now I have implemented, if I did everything right, I have implemented the necessary function write log that we referred to over here in logs proto under the service section. Okay, so now that's complete. Now, we still have no means of receiving requests yet, but at least we have the correct type here, and we have the correct function here. And of course, now we actually need to start listening for gRPC connections. And we'll get started on that in the next lecture. So now that we have the necessary write log function written, we actually have to listen for gRPC connections. And I'm going to do that right here in gRPC Go. I'll write the function that actually starts the listener, and then we'll call it from main.go. So we'll declare a func with a receiver of app pointer to config, and we'll call this gRPC listen. And it doesn't take any parameters, and it doesn't return anything. And this is really simple. I'll create a variable lis for listen while checking for an error when I call from the net package built into the standard library .listen. And I'm going to listen on TCP connections, or listen for TCP connections, and I'm going to listen to this string. And I'll use format.sprintf just to build this string. And my format string is $%s. And the substitution for %s is that constant we made oh so many lectures ago called gRPC port. Okay? And I'll check for an error. If error is not equal to nil, then I don't want to go any further, so I'll just die. I'll say log.fatalf. Log.fatalf, and my format string is failed to listen for gRPC, and then just %v, and I'll substitute error for the %v. But if we get past that, we can now listen for connections. So I'll create a variable called s for server, and I'll call from the gRPC package we imported a couple of lectures ago, new server, right there. So that's created, and now we registered the service. And we do that by saying from the logs package, and that's the one where our auto-generated code is created, we're going to call that function register log service server. And that requires s, which is the gRPC server, and it also requires a reference to log server, which is the type we created in that proto file. And that requires models, which we get from app.models. Okay, so we've registered it, and I'll just print out a message, log.printf, which I have to spell right, printf, and my format string is gRPC server started on port, and then %s, and my substitution is just gRPC port. So that prints out a message. And now we'll just do the listing. If error is assigned the value of from s, the server we created, .serve, and that requires as its parameter lis, our listener. And if the error is not equal to nil, then we'll just say again, I'll copy this, log fatal. And that should be not equal to nil. That's better. Okay, so we have this function available to us. Now let's go over to the main.go file inside of the CMD API of the logger service folder. And down here, we'll listen for gRPC connections. And now that's as simple as running this in its own Go routine and calling app.grpclisten. And in theory, if we got everything right, we're now able to listen for gRPC connections on the port specified by this constant up here, 50,001. Okay? So the next step is to go and create a client to connect to this server. And obviously we're going to do that from the broker service. And we'll get started on that in the next lecture. All right, so far we have defined our gRPC service with a .proto file. We generated the necessary source code in the server, which is the logger service microservice. Then we created the necessary server code, and now it's time to create the client. But before we do that, I did have a little typo in the last lecture, and it's here in the file grpc-go in the logger service CMD API folder in the function we wrote. Instead of typing TCP, which it has to be, I had to type TPC. And I fixed that before I uploaded the source in the last lecture. But in any case, now it's time to go and start working on the client. And we're going to do that in the broker service. And the steps we have to follow, at least initially, are pretty much the same as the ones we followed in the server. We're going to create, at the top level of the broker service folder, a new folder called logs. Okay? And that has to have the proto file. Unfortunately, I can just come down to the logs folder in the logger service, open up the proto file there, select all and copy, close this. Go back to the new logs folder inside broker service and create a new file called logs.proto and paste in the contents. Okay? Now I'll open the terminal window and I need to get inside the broker service folder, which is where I am right now, and I'll go into the logs folder I just created, and that's where the logs.proto file is. And I need to generate the same source code that exists on the server. And I do that with the same command, and I don't want to mistype it, so I'm going to paste it in here, and once again, it's not complex. It's just proto C space dash 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 go underscore out equals dot, and then dash dash go underscore opt equals paths equals source underscore relative space dash dash go dash gRPC underscore out equals dot, and then the source relative bit again here. So type that out and press return, and that will generate some source code for us. And there it is. And of course, we're also going to have to, and I'm going to go up one level to the root level of this package. I need to go and get gRPC. So that's from google.golang.org/gRPC. So go and get that. And I already had it, so. But you need to execute that so that our gRPC code will actually run. So we have the necessary dependency. So I'll close my terminal. Now, the next step is to actually write the code that creates a client to connect from the broker over to the logger service using gRPC. And that's really straightforward. And to keep things clean, what I'm going to do is open up the handlers.go file in the broker service CMD API folder right here. And I'll go to the very bottom of that file and I'll create a separate handler. And we'll create a new root for this. We won't use the /handle root that we've been using for everything else. Just to keep things clean and make it easy for you to find, we'll create a new handler. So I'll declare a function with the receiver of app pointer to config. And I'll call this one log via gRPC. And it's a handler, so it has to have a response writer, http.response-writer, and a pointer to request, which as usual, I'll call r, http.request. Now this handler, like every other handler that we're dealing with in the broker, is going to receive a JSON payload. So I'll declare a variable, request payload, of type request payload. And then I'll just read my posted JSON right into that variable. So we'll check for an error when we call app.readJSON. And that requires W and R, and we're going to read the content into request payload, that variable we just created. If error is not equal to nil, then I'll write back some JSON error. So app.errorJSON, W and the error, and I'll return. If we don't have valid JSON, we can't do anything with it. And the next step is to actually connect to our server. So I'm going to do that using con as my variable name. That's my connection. While checking for an error, when I call from gRPC, that package we just imported, .dial. And we're going to dial to a particular address. And our address, of course, is the logger service, which is logger-service in our Docker Compose YML file. And we're listening on port 50,001. So that's where I'm going. And we have two more arguments we have to pass to this. The first one is, what are the credentials? Because gRPC actually allows you to specify credentials. You have to have valid credentials to connect. Now, we don't need credentials because we're running everything in its own Docker cluster. But it's still, you have to pass a parameter that says, these are my credentials. So we're going to pass, using from the gRPC package, with transport credentials. That's the function we're calling. And we're going to pass it insecure.new credentials, empty credentials. But it has to be in this format, okay? And then get just before the closing parentheses. And the last parameter is, what are the options? And I'm just going to use gRPC.withBlock, with block, which is a function, try that again, with block. And give it its opening and closing parentheses. And again, we have to check for an error, so I'll copy this error checking code and paste it right here. And if we get past that, we don't want to leave that connection open forever, so we'll defer closing the connection, defer con.close. Otherwise, we're going to have connections left open all over the place, and it's a resource leak. So that's my connection. Now, I need to create a client. So I'll create a variable C for client, and that's assigned a value by calling from the logs package, that one we just created where we generated our source code, .new log service client. And that requires a connection, which I just got. So we give it con. And now we need a context because we're going to be using it in a minute. So I'll declare a variable ctx for context and cancel. And those are populated by calling context.withTimeout. And I'll just use context.background, which is always available to me. Context.background. And we'll make it for time.second. If you can't connect in a second, something has really gone wrong because this is a fast transport. And we'll defer cancel. If we run out of time, cancel. And the last thing I'm going to do is to call writeLog, that function we spent all the time writing over on the server. And I do that by ignoring the first parameter. I don't care about that, but I do care about an error when I call see my client.writeLog. And that requires, if you recall, the context, which I just created, and also requires a reference to logs.logRequest, which was specified right in the .proto file. And inside of that, and I'll put it on a separate line so it's easier to see, I'll create a log entry. And that will have a reference to logs.log, and then opening and closing curly brackets. And I populate name with request payload right there, .log, .name, and data comes from request payload, not .action, .log, .data. Okay? And then I'll have to have my closing comma there and give myself some room. And everything else is closed. And we check for an error. So again, I'll copy this error checking code from up here. I just return the error as JSON. But if we get past that, we've actually written to the log using gRPC. So we'll just send a response back. For I'll call it payload. And it's of type JSON response. And we'll say payload.error equals false, which it is by default. And payload.message equals logged. Okay? And we write that out. So app.writeJSON. And we write with W, http.statusAccepted will do the trick. And we're handing it payload. And that should take care of the actual handler. So of course, the last thing we have to do here is to go over to routes.go and create an actual route to that handler. And as I said before, I'm just doing this to keep the gRPC code very separate, so it's easy for you to find and to refer to. So right after this one, I'll just put a new route in here. It'll be a post route, so mux.post. And I'll make the route something really easy to spot. So /log-gRPC, and that goes to app.log via gRPC. And I think that should do it. So now we've got our proto defined, our protocol file, the .proto file defined. We generated the necessary source code in the server. We wrote the necessary code in the server to perform a particular action and to listen for gRPC connections. Then we went over to the client, which is the broker. We, again, copied the proto file over. We generated the necessary source code with that command, proto-c. And we wrote the necessary code to connect to the server and to make a request to it. So the last step will be to go and modify the front end to put in a button that logs things via gRPC and try it out. Okay? So we'll get started on that in the next lecture and find out what we got wrong. So let's go update the front end and try out our gRPC connection. And I'm going to do that by going to the front end right up here and going to the CMD API folder, then to templates, and then opening up testpage.gohtml. And of course, what I want to do is create a new button. So up here under the title, Test Microservices, I'll just duplicate this line. And I'll call this one, I'll give it the ID of log G for gRPC button. And I'll change this to test gRPC log. So I have a button. Now I'll come down to the script section and I'll make a reference to this. So I'll just duplicate the log button and change this to log G button. and change this to log G button. So now I have a reference to it. Then I'll come down here and I'll copy one of these. Maybe this one will do the trick. So I'm copying the listener for a log button, and then I'll just paste it somewhere outside of that function and modify it as necessary. So it becomes log G button is the item I'm listening to. This stays the same. And I'll change this title to some kind of gRPC data, okay? So the payload will stay exactly the same except for the change of the data, so we can verify that we're getting back what we think we're getting back. I still need the headers, I still need the post, but instead of going to /handle down here in the fetch statement, I'm going to go to the route I defined in the last lecture, log gRPC, okay? And everything else, I think, should stay pretty much the same. I see a misspelled error here. I should probably fix that. And that means it's probably misspelled down here as well. Not a big deal, but I like to get things correct. Okay, so now we've modified the front end. The next step is to build everything and to start the front end and see if it works. And we'll give that a try in the next lecture. So we've modified the front end and it's time to test things out. So I'm in my terminal and I'm going to go up one level and into the project folder and I'll type make up_build and build all the binaries and build the Docker images and bring up our Docker compose. So the broker compiled, the logger compiled, that's a good sign. And now it's bringing things up for us. Okay, we need to wait for RabbitMQ to start up, but in the meantime I can type make start and bring up the front end. Okay, now let's go to our Docker desktop. Go to the dashboard and look at the broker service, which is here somewhere. There it is. And we'll wait till it says RabbitMQ is ready. There it is. Now let's go to our web browser and go to localhost. So localhost. And everything seems to be up and running. So let's test the broker, make sure that's working. That worked great. Let's try logging things. That worked fine via RPC. Let's try the test gRPC log. And it says it logged some kind of gRPC data. Now, just to be sure, let's go over to MongoDB Compass and start that up. And click on our recent connection and connect. And go to databases and logs and documents. And we have 5 things in there, some kind of gRPC data. So everything worked exactly as expected. Now, just as a reminder, gRPC is wonderful for communicating between microservices, but at the time I'm recording this, there are only 2 experimental web browsers that actually communicate between the browser and some remote service using gRPC, and neither one is stable. So it's wonderful to communicate between microservices, but at the moment, as I record this, you can't really use it in a web browser. It's just not going to work. Eventually, that'll probably change, but for now, it is a wonderful way of speeding up communications on the back end. Let's move on. In this section of the course, we're going to be looking at one way of deploying our microservices to some production servers, and that's Docker Swarm. Now, undoubtedly, you've heard of Kubernetes. And don't worry, we'll be looking at Kubernetes in the next section of the course. But in a lot of situations, Kubernetes is really overkill for a particular company or individual's needs, particularly if you don't have a dedicated person or team who works on Kubernetes all day, every day. There's an awful lot of moving parts in Kubernetes. Docker Swarm, in contrast, can easily be managed by an individual person, and that person doesn't have to work on it all the time. And certainly that's my own situation. Although I do work with Kubernetes on a regular basis, in my own projects, when I'm deploying things for my own clients, I tend to favor Docker Swarm. Now, you may have seen some posts on the internet. There are lots of discussions about this on Reddit, for example, that suggests that Swarm is dead, and nothing could be further from the truth. If you're interested in looking into this in more detail, I suggest you Google Brett Fisher, who has an excellent course in Swarm and Docker and Kubernetes on Udemy, and look at his posts about this. Swarm is being used by lots of large companies. There's a commitment from the organization that develops it to keep it active. And I think in a lot of cases, it could be just what you see right here. This is linked to in the course resources for this lecture, and this is the page about Docker Swarm. And you notice this line, do not confuse Docker Swarm with Docker Classic Swarm, which is no longer actively developed. And as far as I can tell, that's probably the main reason why people think Swarm is dead. It's not. It's great, it's rock solid, and it's remarkably easy to use. Now, as I said, we're going to be looking at both Docker Swarm and Kubernetes, and you can make your own decision once you finish those and decide which one is appropriate for your use case. But this section is all about Docker Swarm. And Docker Swarm is nothing more than a container orchestration service. And you can look at some of the features it has right here, and I'm not going to read them all to you, you can read them on your own. The simple, short story is that it allows you to deploy one or more instances of a Docker image and have Docker Swarm take care of how those instances are deployed. So for example, I could go on to Linode or DigitalOcean and create, say, 3 nodes, 3 individual server instances, add each one of those to Docker Swarm, and deploy my microservices up there. And Swarm will say, okay, where do you want to put this container? Where's the appropriate place to put this? And it manages keeping them up, keeping multiple copies of them up when necessary, and it makes it remarkably easy to scale your microservices. So if you're really successful and you deploy your application to 3 nodes and you discover that the load on the server is very heavy, you can easily add 1 or 2 or 10 or 50 nodes right from the command line, and Docker Swarm takes care of everything else. And the great thing about Swarm is it's easy to use. So let's get started building some Docker images and pushing them up to Docker Hub, and we'll get a Swarm up and running. So before we can actually use Docker Swarm, it will be helpful, and actually almost essential, to build and tag images, Docker images for each of our microservices and push them somewhere. And we're going to push them somewhere because when we deploy our Docker Swarm, we need to pull those images. So the best place to push these for our purposes in this course, in any case, is to go over to this site. And we've been here before, hub.docker.com. And you'll need to create an account, and it's free to create an account. And although there is a paid tier for this service, and it's relatively inexpensive, but you don't need to pay for it. We're never going to hit our limits pushing and pulling for the duration of this course because you have a fairly big daily limit for pushes and pulls. So create an account there, and then we'll build and tag some Docker images. So let's go back to our IDE. And in the terminal, I'm going to do one for the logger service. There's only 2 commands required to build and tag the Docker image and then push it up to Docker Hub. So I'll do it for a logger service, and I'll leave it as an exercise for you to do the other 4 because it's pretty simple to do this. So make sure you're in the logger service folder, and let's build and tag a Docker image. And we do that by typing docker space build-f, and we specify the Docker file. And mine's called logger-service.docker file. And then -t for tag, and I'm going to tag it with my username. Now, when you created an account on hub.docker.com, you got a username. Mine happens to be tsolar. And of course, you can't use mine because you won't have permissions to push it there. So make sure you use your own username. And then I'll put logger-service, and then the version. And mine is version 1.0.0, okay? And then a space, and then a dot. And that will build the Docker image and tag it. So now I have tsolar/logger-service:1.0.0 built and tagged. And now I need to push it up to Docker. And then type docker push and the one you just built and tagged. In my case, it's tsolar/logger-service:1.0.0. Now, as you can see, I've not actually logged in on this particular machine, which is good because now you can watch me log in. So logging in is as simple as typing docker login. And we'll ask for my username, which is tsolar, and then my password, which I type in. And now I'm logged in. So I'll clear the screen. And I'll hit the up arrow until I get back to my Docker push command. And there it goes. It's pushing it up to Docker. So you're going to do that same series of commands for each one of your other services. So for the broker, for example, you'll go up one level and into your broker service folder. And then again, you'll type docker build -f and your Docker file. And mine's called broker-service.docker file. Then you tag it with your username and whatever name you want to give your image. So I'll call mine broker-service : the version, and then a dot. And when you've done that, I'm not going to bother doing that right now, but when you've done that, your next command would be docker push your username, the name of your image you just built, : followed by the tag, and you hit return, and it pushes it up there. So get all of your microservices images pushed up there, and we'll move on in the next lesson. So as you can see, I've pushed all of my microservices up to Docker Hub, and they're all set to go. So I have the listener, the mail, the authentication, the broker, and the logger. And I have other ones that you can ignore because they have nothing to do with this course. So hopefully you have all of your microservices pushed up as images, because if you don't, nothing else is going to work for you. So make sure you have them all up there. Now, let's go back to our IDE. And inside the project folder, I'm going to create a new file in here. Okay, so a new file. I'm going to call it swarm.yml. And this is very similar to the Docker Compose file. But instead of bringing some images up for development, this will allow us to create a Docker swarm. Okay? Now the syntax is very similar, but it's not identical. So I'm going to start right from scratch. The first thing I'll have, the very first line in this file is a version line. Version : and then I'll put in single quotes the number 3. That's the version I'm going to use. And then I specify my services. Services, plural. Okay? And again, this is YML, so tabs and indentation really matter. Now, the very first service I'm going to put in here is the broker service. So I'll call it broker-service. And I'm going to use exactly the same names for the services here as I did in my Docker Compose. And it's pretty important that we do that, because if we name the services the same as we did in our Docker Compose file, then we don't need to change the URLs we call for each of those services. So when the broker service calls the authentication service, for example, in our code, it's expecting it to be called authentication-service. So I'm using exactly the same names here. So I have the broker service, and then I indent, and I say, what image am I going to use? And I'll specify the exact image that I just pushed up to Docker Hub. So mine is tsolar broker-service : 1.0.0. Okay? And then, does this have any ports? Yes, this is going to have ports that communicate with the outside world. So ports : return tab -space, and I'm going to have port 8080 on my local machine or exposed to the outside world go to port 80 for the actual Docker image itself. Okay? So when I have this up and running, which we'll get to eventually, I'll be able to hit the broker service by calling port 8080. Okay? So we'll do that. Then, back at the same level as ports, we're going to use deploy. And in this case, I'll tab in once and say mode is replicated. I can have more than one instance of this running in the swarm. And initially, I'll have replicas set to 1. And that's it for the broker service. Now let's go back over to the same level as broker service, and let's do the listener-service : return tab. And it has an image, and the image is tsolar /listener-service : 1.0.0. And this one doesn't have any ports, so I just need the deploy section. So I can just type deploy. Mode is replicated. And replicas I'll set to 1 initially. So there's our second service. Now our third one, let's do the authentication service. Authentication-service. And make sure you spell these right or you're going to have problems. And the image is tsolr/authentication-service : 1.0.0. And this one I'll deploy. And its mode will be replicated. And its replicas will be 1. Now, if you go over and look at our Docker Compose file here, and you find the authentication service, it also requires an environment, okay? So we're going to have an environment variable here as well. So let's backspace, and we'll put environment, and it's going to have a DSN, and I can probably just copy the one right out of Docker Compose. So I'll copy this and go back to Docker Swarm or Swarm YML and paste that in there. Okay, so that means when we have our Postgres image, which we'll add here before too long, we're going to have to name it Postgres or this won't work. So there's our authentication service. 3 out of 5. Let's keep going. Number 4 will be the logger service. And it has an image, and that's in my case tsolr logger-service : 1.0.0. And we'll deploy this with the mode replicated and replicas 1. And that should be it for the logger service. And the last microservice is going to be, of course, mail-service. And it has an image, tsolr mail-service : 1.0.0. And its deploy is mode replicated, and replicas will be 1. Now, just as we did with authentication service, if we go over to the Docker Compose file, we have environments for the mail service as well. Now I called mine mailer service here, so I better call it mailer service back over here. I'm glad I noticed that. But I need to copy the environment, so I can copy all of this and go back to swarm.yml and make sure I'm at the right level, at the same level as deploy, and paste that in there. And that should be just fine. So those are our microservices. We have 1, 2, 3, 4, 5 set up. And we could add the front end here, and we might later on, but right now we're just going to get this up and running and see how Docker Swarm works. But we're also going to need RabbitMQ and MailHog and Postgres and that sort of thing. So let's get started with RabbitMQ. RabbitMQ, which is exactly what I called it over here in Docker Compose, I think. Let's make sure. RabbitMQ, yes. Okay, so I can copy the image part and paste it in here. And this time, I don't want multiple instances of RabbitMQ running. I just want one. So I'll say deploy. But this time, mode will be global, which means I'm only ever going to have one instance of this, okay? And RabbitMQ actually requires some data as well. And if I don't specify a volume someplace outside of the container, it will actually run it right in the container itself. And for my purposes, for development, that's fine. But in production, of course, you're probably going to want to read up on Docker volumes and actually have a fixed volume for your production swarm. But we don't need it for development, just to test things out. So there's RabbitMQ. And let's do the same thing for MailHog. And we'll give it an image. And we can use the one we used before, which is mailhog/mailhog : I'll just use the latest version. It rarely changes. And it's going to have ports, because I'm going to want to be able to connect to the web interface for this. So I'll say port 8025, which is the web interface, maps to port 8025 on the Docker image. And for this one, I only want one instance running again, so I'll say deploy, mode is global. Okay, we're also going to want Mongo. So let me scroll up and give myself some room. And I'll say Mongo is the name because that's what I called it on the other one. I better make sure. Docker compose. Where's Mongo? Yeah, I called it Mongo. Okay. So it has an image. And I'll use the same one I did before, which is Mongo : 4.2.1717 -bionic. And I might want to connect to this from the outside world. So I'll say ports. And again, I probably wouldn't do this in a live production swarm, but I want to be able to connect to it locally once I have the swarm up and running to make sure everything works. So 27017 is mapped to port 27017. And in this case, we'll deploy it again with the mode of global. Only want one instance running ever. I do require some environment variables, so I can go copy those right out of here. Actually, I can copy all of this out of here. Probably could have copied the whole thing. And I'll paste it in. Now, in this case, you'll notice that I have the volumes specified. And that says, when this Docker image comes up, map the local directory db data, which exists right here, to the appropriate directory in the Docker image. And this means that Mongo won't lose all of its data every time I start up the Docker swarm. It'll persist between restarts. And that's fairly important for database data. So there's Mongo. And we're also going to want Postgres. So what I can do is get to the right level, go over to Docker Compose, find Postgres, and just copy it. It should be exactly the same. So I'll come back over here and paste it in. Now, a note about this. We're going to be starting Postgres and Mongo right as in the Docker swarm as part of the swarm itself. I almost never do that. Some people do. I don't. I almost always have Postgres running as its own instance on its own server, and I connect from the swarm to Postgres. And I make sure they're in the same data center so latency is not a real issue. And in a lot of cases, I'll actually purchase and pay for on a monthly basis a managed database from Linode or from Amazon or from DigitalOcean. It's available on all of those services, and I'll buy it that way. Right now, Postgres is not available on Linode, but MySQL is, and Postgres is coming later on. But if I need Postgres, I'll just deploy to DigitalOcean and use their managed database. It just makes life ever so much simpler. But in our case, we can run this just perfectly in a Docker swarm, and lots of people do it. I just tend not to. It's a personal preference. So we have everything all set up, as far as I can tell, in our swarm.yml. So in the next lecture, we'll try bringing the swarm up and see what happens. Okay, so we have this swarm file, and now it's time to initialize and bring up our Docker swarm. But I did have a typo, and I'm sure you noticed it right here. In the file swarm.yml, which is inside the project folder, under the mailer service, I misspelled replicated. So let's fix that. And there's probably other typos in here, but we'll find out shortly. Now, to initialize Docker Swarm, let's open our terminal, and I'm going to go up into the project folder, because I need to be there in a minute. And to initialize it, all you have to do is type Docker Swarm init. Now, this gives me some feedback, and you need to pay attention to this. We're not going to use it here, but when you're actually deploying to a cluster of servers, anytime you start up a Docker swarm, one node, at least one node, will be the manager, and that's what actually handles the orchestration of all of our various Docker images. When I want to add another node that's not a manager, let's say I'm getting lots of traffic and now I need to add a second or third or fifth or 75th node, whatever it is, I'll spin up that new server, set up its firewall and so forth, and then I'll type this command, or copy and paste it actually, this one, and that will actually add a worker to this swarm, okay? Now, if you need to add a second manager, and if you have a large cluster, it's a good idea to have multiple managers in case one dies, you're going to run this command, docker swarm join-token manager, and follow the instructions. Now, if you don't copy and paste this, don't panic. You can always get the token back, and I'll just clear the screen, by typing docker, try that again, docker swarm join-token. And if I want to add a worker, I just type worker. and it gives me the appropriate command. And if I want to add a manager, I just change worker to manager. And there's the appropriate command for that, okay? So those are always available to you. Now we've initialized the swarm, and if I do an ls, or dir if you're on Windows, there's my deployment file, swarm.yml. Before I bring it up, let me go to my Docker desktop and make sure I don't have anything running. And I do. So I have my Docker Compose running. So since I'm in the project folder, I'll just type make stop. And that stops the front end. And make down should bring down my Docker Compose. And there, everything's down now. So I'll clear the screen. And to actually deploy my Docker swarm, this is the command I need to execute. Docker stack deploy -c for configuration, and then the name of my file, and mine's called swarm.yml. And then I have to give this swarm a name, and I'm just going to call it my app. You can call it whatever you want, as long as it's not multiple words, but my app will do the trick for me. So now, when I hit return, it creates the necessary networks and services, and it'll take a moment to start them all up. And then, of course, they'll actually have to, some of them have to wait till the database is available, until the RabbitMQ is available, and so forth. But they're all starting right now, okay? So we should, if I type this command, let me clear the screen, type docker service ls, it shows me that I have one replica for each of these things up and started. And you notice the third column actually tells me whether it's replicated. In other words, I can have more than one instance of that image, or whether it's global, and I can just have one. And it also tells me what ports it's listening on. Now, as you can see, we're listening on port 8080. And when we start up the front end and try this out shortly, that's the port we'll be connecting to. And we don't have to make any changes to the front end because it's already connecting to port 8080. But we can also hit mailhog on port 8025. And we can hit Mongo and Postgres. And as I said, I probably wouldn't expose those ports in production. That's not entirely true. I would expose them. I would just make sure that the firewall on my server doesn't allow any external traffic to those ports. And if I needed to hit Mongo, I would just use an SSH tunnel. Same thing for Postgres, okay? But these are up and running right now. And in the next lecture, we'll try connecting to it and then try scaling some services and just playing with our Docker swarm. So we appear to have our Docker swarm up and running, and now I want to make sure I can actually hit it. So to do that, I'm in the project folder, right where I left off last time around. I'll just type make start, and that will compile and start the front end application. And there it is, it's running. So now I'll switch to my favorite web browser, and I'll just go to localhost. And well, we hit it, that seems pretty encouraging. So let's try testing the broker. And I got error false, hit the broker. Perfect. Let's try authenticating and make sure we actually have access to our Postgres database. That seemed to work really well. Let's try logging. That worked. And let's try sending a mail. And over here, I have Mailhog running in another tab, so I should be able, there it is. We got the message, no problem. And the last one is testing gRPC. And that worked really well. Okay, so we seem to have our swarm up and running, exactly as expected. Now, obviously, when we put this into production, and we'll be doing that later on in this section, we'll actually put it onto some servers on Linode. We're going to make some changes to the deployment file, swarm.yml, because I don't want to listen on port 8080 for my backend server for the broker, and I don't want to have my front end running separately. I want everything in one file. And that means we're going to have to add a couple of things. We'll have to add the front end, for example, as a service. And we'll also have to add some single point of entry. Now, we can have multiple instances of that single point of entry, but we're going to want something like Nginx or maybe Caddy to act as a front-end proxy server. So that way, we can have Caddy running, or Nginx, or whatever web server we choose. We can have the connections encrypted using SSL with probably Let's Encrypt. And all that front end will do, the proxy server, is listen for requests based upon domain name and forward them to the appropriate microservice in the backend. But it'll be a little while before we get there. Right now, we're pretty sure that things work, so let's play with Docker a bit, Docker Swarm, in the next lecture. And we'll try scaling some services. So we have our Docker swarm up and running, and everything seems to work really well. But right now, we only have one instance of each of the services. And I'm back in the project folder, and I'm going to clear the screen in my terminal. And remember, you can list your services by typing docker service ls. Okay? And that lists them all. And as you can see, each service has a unique ID in the first column. Each service has a name, and it always begins with whatever I named my swarm when I deployed it with that command docker stack deploy -c, the name of the configuration file, and then the last bit was the name. And I called mine my app. So the authentication service in this case is called my app _ and then the name of the service. And the same for the broker, the listener, so on and so forth. Now, one of the great things about any container orchestration service is we can have multiple instances of many of our services. Not all of them. For example, the ones that are global here in the mode global, we can only have one of those. But if I want to scale a service up, it's literally as simple as typing this: docker service scale, and then a space, and then the name of the service. And remember, it starts with my app. So I'll scale up, say, the listener service, my app _ listener, which I have to spell right, -service equals, and I'll make it say 3. I want 3 instances up and running. And I hit return, and there, they're all up and running. Now, they might have to wait a little bit while they connect to the Mongo or whatever it is, but that's all we have to do. Okay, so it's up and running. So now if I clear the screen and type docker service ls, it lists them all, and now I have 3 instances here of the listener service. And if I want to take it down to 2, I just, again, use that scale command. I just hit the up arrow to bring it back up. I'll just change it to 2. And it actually stops 1. And it waits until that services are stable and everything's converged. That means it's all doing exactly what it should. So if I clear the screen and type docker service ls, I should have 2 instances. And I do. So that can be incredibly useful when you want to have multiple copies of your services running. And the other great thing about this is, if something goes wrong, if, for example, the logger service suddenly dies, Docker Swarm will just create another instance and bring it back up. So it keeps things up and running for me. And that can be incredibly useful, even if you're running everything on a single server. In other words, you have one node in your swarm. This is a convenient way of having multiple instances of what you need to be running, and to ensure that they stay up and running. Okay? Now, of course, we've deployed this application, but applications don't remain static over time. Occasionally, quite often actually, you're adding functionality or changing something, and you need to update your Docker Swarm. And the process for doing that is relatively straightforward. And we'll go through that in the next lecture. So this time around, our goal is to look at how we actually update services. In other words, we make some change to a code base. We need to get that into Docker Swarm somehow. And not surprisingly, it's not that difficult. So let's assume that we're actually making a change to, say, the logger service right here, okay? So I'm actually not going to make a change to it, but pretend we added a new function of some sort, whatever it may be. And I now need to actually get that into my Docker Swarm. So what I need to do is to go into the logger service folder, clear the screen, okay? And here's where my logger service Docker file is. So what I need to do is to build a new tagged version of this and then push it up. And we know how to do that. It's docker build -f, the name of your Docker file, and mine's called logger-service.docker file. Then we tag it. So I use my username and the name of the service, and I'm going to use the same name I did last time, logger-service, but this time it's version 1.0.1, then a space, and a dot. And it will build very quickly because there are actually no changes. We're just pretending there's changes, okay? And now I push that up to Docker Hub with the command, and I'll clear the screen, docker push tsolr/logger-service : 1.0.1. And I let it push it up. And there was no changes, so it took almost no time whatsoever. But now I have a new tagged version of that up and running. So I'm going to go back into my project folder, okay, and clear the screen. And now I actually want to update the version that's running in my Docker Swarm. So let's see how many instances, Docker service ls, how many instances of the logger service I have running. And I have one. You can see it right here, 1 of 1. Anytime I update a service to a new version, I want at least 2 to be running. And that's because when I update the service with at least 2 going, there'll be almost no downtime, probably no downtime, because it updates the service 1 at a time for each instance. So let's scale the service. Docker service scale, I'm going to give it the name, myapp underscore logger dash service equals 2. So that should bring 2 up. And it waits. Okay, so let's do a Docker service ls, just to make sure there's 2 running. And there is. Now, I'm going to update my logger service to the new version. And that's really simple. Docker service update dash dash, you specify the image space, and I'm going to specify tsolver logger dash service colon 1.0.1, the one that I just pushed up to Docker Hub. Now I specify the name, myapp underscore logger dash service. Okay? So I'm telling it to update that service using this image, and then I provide the service name. So let's hit return. So it does them 1 at a time. And that's what makes sure that we have very little or no downtime. Perfect. Now let's clear the screen and do a Docker service ls. And you can see it's now been updated to logger service 1.0.1. Okay? And you can downgrade things as well. Let's say that oh no, I just launched a new logger service that has a big bug in it. Well, I could just do the same thing. This Docker service update, but roll this to the previous version. And that will take care of it. Okay? So updating services is pretty trivial. And I'm sure you've noticed this with other projects, but you can actually automate this service with continuous integration. I'm not going to go over that because there are so many different ways of doing it. And personally, I never use it. I just update things manually because I'm not an optimist when it comes to automated tasks, at least ones written by other people. In any case, let's move on. So at some point, you're going to want to stop Docker Swarm. Certainly, you're going to want to do it here on your development machine, but even in production, maybe you need to do some server maintenance, whatever the case may be, but you have to stop it. So back in my terminal, in my project folder, right now, if I do Docker service ls, I have all these things running. And what you can do, of course, is Docker service scale. And whatever service you want to bring down, say you want to bring down the broker, myapp underscore broker service equals 0. And that will scale it down to 0. And you can do that for as many of the services as you need to. And that will actually stop the swarm. It still exists. It hasn't been removed yet. But at some point, if you want to actually remove the entire swarm, you can do it like this. Docker stack, not swarm, rm, and then the name of whatever your application is. And mine's named myapp. And if I do that, and now do a Docker service ls, and I'll clear the screen, there's nothing running, okay? And to entirely leave the swarm, say you're done with this server for whatever reason, and you're removing it, maybe it's a worker node you no longer need, you can just say Docker swarm leave. And in this case, it'll tell me I have to force it because it's a manager, which is a good thing. You don't want to accidentally delete a manager. So I just put -- force at the end. And now it's left the swarm, okay? So the next step is to take what we've learned so far and apply it to actually putting a live swarm up on a cluster of servers. And we have some changes we need to make to our actual Docker images, and we need to create a couple more, but we'll get started on that in the next lecture. So at the moment, when we run our Docker swarm, we actually have everything in the swarm except for the front end. And of course, that makes no sense. We want to put the front end in there. So what we need to do is to build a version of the front end as a Docker image. And there's a little change I'm going to make in order to make that happen. We'll also need to make some changes here in our swarm.yml. And one thing I never mentioned, of course, was over here in swarm.yml, inside the project folder, under the logger service, we did an update of that to version 1.0.1. And of course, we pushed that to the actual active swarm, but we never updated this file. And of course, when you update the file, you should update the version. When you update a Docker image, you should update the version. Okay, now the other thing I'm going to do here is right now we have the broker service listening on port 8080. And I'm going to leave that alone. That's fine. But I'm going to change the port on the back end for the actual microservice itself to also be 8080. And you'll see why when we actually put a web server as our single point of entry into the swarm. So to make that happen, I'll go over to the broker service, into the CMD API folder, open main.go, and just change this constant to 8080. Okay? All right, that was easy. Now, let's rebuild that and tag it as version 1.0.1. So I'll open my terminal window. And in the project folder, I'm going to type make build_broker. And that should build a new version of the actual broker service as a binary. So that's built. Now I'll build and tag the new Docker image. So up one level, into the broker service folder, clear the screen, and we'll type docker build-f, and it's the broker Docker file, broker-service Docker file. And we tag that as, in my case, tsolr broker-service : 1.0.1, because it's a new version, space dot. And that will build the new version of it. And now I push it up to Docker Hub. Docker push tsolr / broker-service : 1.0.1. There, it's all pushed. Now we'll go back to swarm.yml, and I'll find the broker service and change that to 1.0.1. And I actually don't need this port section at all because I'm not going to expose this to the clear internet. Instead, I'll be proxying from Caddy or Nginx or whatever web server I decide to use to the microservice. Okay, so I don't need to expose any ports on that whatsoever. And I probably could leave that at port 80, but I just want to make sure things are absolutely clear. Okay, so that's done. Now, the next thing I want to do is make a change to the front end. So I'm going to be building this as a microservice. And one of the things I want to do is to actually move the templates right into a read-only file system. It's just cleaner that way. So I can leave the folder where it is right now, and all I have to do is go to main.go. And down here in the render function, I'm going to add some logic here. So I'm going to add, as a comment, which seems weird, but this is the way Go's embedded file system works. / for the comment and no space. Don't put a space in there. And then Go : embed. And I'm going to embed the templates folder. Okay? And then underneath that, I create a variable, which I'll call template.fs for template file system of type embed.fs. And that should do the import for me. Okay? Now in the render function, I'm no longer going to refer to things using this kind of syntax. Instead, I just delete the first part, the ./command/web/. I just start with the word templates. So I'll do that for all of these. And then down here, I'm going to do exactly the same thing. Okay? Delete that part of the string. And then down here, where I parse the templates on line 41 in my code, instead, I'm going to parse an fs. And that requires one additional argument at the beginning, and that's the variable we just created called template.fs. Okay? And nothing else should actually change here for this part. Now up at the top, I'm going to make this listen on port 8081. Okay? Now the broker's on port 8080, and now this is going to listen on port 8081. So I'll change my comment as well. And save this. So the next step is to actually create a Docker image of this, build it, tag it, and push it up to Docker Hub. And I'm going to leave this as an exercise for you. You give this a try. You should be able to, at this point, to build a Linux executable. You'll have to add something to your makefile, of course. And you should be able to write the necessary Docker file and actually build the Docker image and push it up to Docker Hub. So give that a whirl, and in the next lecture, I'll show you how I did it. So how did you make out with that challenge? I suspect you didn't find it terribly difficult. But in any case, here's how I did it. And I'll look at the makefile for Mac and Linux first, and the one for Windows after that, because that's where I started. So in the makefile, I added here a new variable, front_binary. I already have a front-end binary I used to start that, and I'm not going to use that anymore, but I left it there as a reference. So I created a new one with a different name. Instead of calling it front app, I called it front-end app. Then I just came down here to the section just before build broker. I copied that, pasted it here, and modified it. I called it build_front_Linux and changed the comment. And then I named it build_front_Linux, changed the echo statement here, and just made sure it compiled the correct thing using the correct name, and it's ./cmd/web. So that was easy enough. And in the Windows makefile, I did pretty much the same thing. I put in the same variable here at the top, named front_binary, and that's the name it's going to compile to. Then down here, I just copied the broker section, pasted it here, and named it build_front_Linux, build_front_Linux here, changed the echo statement, and compiled it in the front-end directory, and everything else is pretty much the same. Okay? So once I had that done, then I opened my terminal window, made sure I was in the project folder, and I typed make build_front_Linux, and that built the Linux executable for me. Then I created a Docker file, and I made that right in the front-end directory at the top level. So it's called front-end Docker file, and it's dead simple. All I'm doing is copying from Alpine Latest, making a directory on the Docker image, copying the binary into the app directory, and starting it. That's it, okay? So that was pretty straightforward, and I suspect you had no problems with it whatsoever. Now the next step, of course, is to go over to our swarm file and add that image to the services to make it available to us, okay? And then after that, we'll have to add in a front-end proxying web server. So we'll get started on those things in the next lecture. So now that we've built and pushed up an image of our front end to Docker Hub, and you can see that I've done that right over here in my web browser, I have tsolr front-end tagged as version 1.0.0. The next step is to go back to our IDE and add it to this file, swarm.yml. So right at the top of the services, before the broker service, I'll hit return a couple of times and tab into the right level, and I'll add front-end. And it has an image, and that's tsolr front-end : 1.0.0. And we want to deploy this, and the mode will be replicated. And initially I'll just go with replicas 1. Okay? So that's been added to our Docker swarm. Of course, the problem with the swarm right now is we can bring it up easily enough just by typing the appropriate command at the command line, but we have no means of actually accessing the front end. So the next step is to put in a proxying web server. And what that proxying web server will do is it will take all requests for the front end, for the broker, those will be the two that we'll be hitting, and it will route them to the appropriate microservice. And we'll get started on that in the next lecture. So as I suggested last time, our swarm file is just fine the way that it is, and we can bring up a Docker swarm, but we actually have no way of hitting the front end. There's no ports exposed here in the front end section. In fact, the only exposed ports are for Mailhog and Mongo and Postgres, and that's really not going to help us hit our web application. So what we need to do is to install another image into our swarm That's a simple web server, a web server that will take requests and forward them to the appropriate microservice. In other words, a reverse proxy. Now there's lots of web servers to choose from. We could go with Apache or Nginx, and if you're comfortable with those, you may want to use that. But I'm actually going to use this one. Let me switch to my web browser. I'm going to use Caddy, and Caddy is a really, really good web server. It's actually written in Go. And one of the nice things about it is it handles installation and deployment of SSL certificates automatically. We don't have to do anything. As long as we have an appropriate domain name, we've registered a domain name and we have the appropriate entry in the name servers, it just magically puts all of the SSL certificates in place for us. And it uses Let's Encrypt, which is extremely popular and doesn't cost anything. So this is the one I'm going to use. And if you go over to Docker Hub and search for Caddy, you'll see that there's already Docker images up on Docker Hub that we can use as a starting point. So let's get started. I'm going to go back to my IDE. Now, if you look at the course resources for this lecture, you'll see that there is a zip file you can download. Download that, extract it, and you'll find two files. One is called caddy.dockerfile, and the other one is called caddyfile. And these are the two files that are necessary for us to be able to build the appropriate image for our swarm. Let's have a look at the Docker file. All that this does is it says from caddy 2.4.6-alpine. That's our starting base image. And we're going to copy into our own Docker file the caddy file, which is the other file we have in our zip file that you downloaded. And we're going to put it at this location in the Docker image. So we're basically specifying our own version of configuration for Caddy. Now let's have a look at that Caddy file, okay? And this is what I like about Caddy, is it's so easy to work with. So at the very beginning, inside of curly brackets, we have one directive, email, and I put you@gmail.com. I suggest you put your own email here. And this is in case Let's Encrypt needs to contact you about a certificate. So put a valid email address in there. We're not going to be using SSL until we deploy this on a live server, but we'll get to it eventually. The next section is something that will apply to any server, any virtual host that refers to static, okay? And all this says is for things that end in any of these extensions, in other words, static assets, cache them. Tell the browser to keep them for this many seconds, which is a long time, okay? It just saves traffic to and from our web server. This next section we're not going to be using until we actually go live. And this is just a configuration that says if you're using SSL, if it's on port 443 and you have an SSL certificate installed, enable the header strict transport security. In other words, don't let people visit the unencrypted version of our site. If they try to, just redirect them to the appropriate one, okay? And here is where I specify two servers. This first one, I'm just going to call it localhost for development on our own machine because that's always available to me. Any request that goes to localhost port 80, we're going to encode it using ZSTT and gzip. We're going to make it the file as small as possible before we send it. We're going to import static, so that says import this information up here. In other words, cache static content for a very long time. And then we're going to reverse proxy to front-end. And of course, that is over here in our swarm.yml. That's what we just added in the last lecture, this microservice. So forward it there. And for any server called backend, and we actually don't have a backend yet, but we're going to add that to our hosts file in the next lecture, any request to port 80 for the server named backend, send that to the broker service. And you'll notice that I have the front end going to port 8081 as we specified, and the backend, the broker service, going to port 8080. Now, I'm sure you're aware of this. We could just have both of those microservices listen on port 80 and leave off the :8081 and leave off the :8080 for the broker service. The only reason I did that is just to make it absolutely clear where things are going. And if you want to remove that, you can do so, but you'll have to make the change to the port that the appropriate microservices are listening on. And that's just a constant at the top of the main.go file for each service, so that's trivial. But I'm going to leave it like this, just to keep things really clear, okay? So we have these things. Now the next step, of course, is to actually build a Docker image and push it up to Docker Hub. And we already know how to do that. So I'm going to open my terminal, and I'll clear the screen. And I'm in the project folder, and I can verify that. And here I see the caddy.docker file, and I see the caddy file. So let's just build an image. So I'll say or docker build -f, and I'm going to use caddy.docker file. That's my Docker file I'm going to build from. And I'm going to tag this as, in my case, tsolr, and I'll call it micro-caddy. Okay? And I'll tag it at version 1.0.0, and then a space, and then a dot. So that will build the Docker file for me. Perfect. Now let's push it up to Docker Hub. So docker push tsolr / micro-caddy : 1.0.0. And that pushes it all up to Docker Hub for me. And now it's available. So I'll close my terminal window and I'll go back to my swarm.yml and I'll add that at the top of the services. And it will become a service that's available to me. So I'll hit return, get to the appropriate tab level, and I'll just call this caddy. And it has an image. And we just push the image. Mine is called tsolr / micro-caddy : 1.0.0. And I'm going to deploy this, and its mode will be replicated. And initially I'll have replicas of 1. And the other thing I want to do with this, of course, is this is how we're accessing our swarm. So I'm going to have some ports. And my ports are going to be port 80 goes to port 80 in the container. And also, we're not using this for a while, but port 443, which is the secure port, SSL encrypted, is going to go to 443 in the Docker container as well. Okay? And I'm also going to add volumes for this. And in the Docker world, volumes are a way of having something on some other file system available to the Docker image in question. So, when we deploy this to a live server, we're going to be using port 443. And this means that caddy has to have somewhere to store the certificates that it pulls down. Now, it would work for a little while if we just didn't specify any volumes. It would just say, okay, I'll put my certificates I'm getting from Let's Encrypt right in the Docker image. And the problem is, of course, that Docker images in a swarm or in Kubernetes, these are ephemeral. They don't live forever. They might disappear and come back. And eventually what'll happen as these Docker images disappear and get reinitialized and redeployed, it'll keep requesting certificates over and over and over. And Let's Encrypt is a great service and it's free, but it does have request limits. You can't request too many certificates or it says, sorry, I'm going to stop you from requesting certificates to this IP address for the next 7 days or something like that. And that might mean that you can't actually get a security certificate for up to a week, which means you have downtime for up to a week. So instead, we'll specify some volumes. So I'll put in the keyword volumes at the same level as ports, volumes, and a colon and return. And I'm going to specify 2 volumes. The first one will be a folder I'm going to create in a minute called caddy_data, and that will map to /data, which is where it exists on the Docker image. And the second volume I'll specify is caddy_config, and that goes to /config, which is where it's expected to be found in the Docker image. Now I specified my volumes here, and what I'm going to do now is go to the very bottom of my Docker file, and I'll hit return a couple of times. And I'll go right over to the left margin, okay? So as far to the left as I can go, and now I'll say volumes. This is just telling my swarm where to find this data. And we're going to say caddy_data, return, tab, and I'll just say external is true, okay? And then I'll backspace to get to the same level as caddy data and just say caddy_config. And that's all I need to do. And this is sufficient to get our Docker swarm behaving as it should. Okay? So we've built our caddy image. We've copied the appropriate caddy file into that image before we built it. Then we pushed that up to Docker Hub. And up here, we've added caddy to our Docker swarm configuration, the file swarm.yml, specified all of its necessary settings, and specified its volumes as well. Okay? So at this point, I should be able to bring up my Docker swarm and hit the front end. And we'll give that a try in the next lecture. So we now have our swarm.yml, our deployment for our Docker swarm. We have that file updated to include caddy. And we also have it updated to include our front end. So we have 2 new microservices here. And we also specified 2 folders, caddy data and caddy config. So we probably should create those. It might start up without them, but it only takes a second to create the folders. So in my project folder, I'll create a new one called caddy underscore data, which I have to spell right. And another one called caddy underscore config. Okay, so that's done. Now, the next step, if you recall, over in our caddy file, which is now part of our caddy image, we're specifying 2 domain names, 2 virtual hosts. One localhost listening on port 80, and make sure you include that there, or otherwise it'll try to fetch an SSL certificate using Let's Encrypt, and that won't work. And another one called backend. Now, localhost is no problem. That's available on pretty much any machine, but we need to specify backend. Now, if you're on Mac or Linux, you can follow my steps. And if you're on Windows, I have a resource I'll point you to in a moment. But for Mac and Linux users, open your favorite terminal and type sudo vi/etc/hosts. Okay? And if you've never used the Vim or Vi editor before, don't worry. It's pretty simple for what we're going to do. So press return. And it will ask you for your password, the one you used to log into your computer. And it doesn't show when you type it. You probably noticed that. And here's my hosts file. And anytime you try to go somewhere, your computer will always look in your hosts file first to see if there's an entry. And if there's not, then it goes out and questions a name server and says, give me the IP address for whatever I'm looking for. So what we're going to do is we're going to come down here to this line. You'll have a line called 127.0.0.1 that is localhost. And I'm going to use the arrow keys and go to the end of it, right to the very end until I can't go any further. Then I'll press the letter A, okay? And I'll hit space, and I'll type in here back end, which is what I specified a little while ago, okay? And down here, for IP version 6, the line that starts with 2 colons and 1, if you have one of those, keep going, or get to the end of that line, press A if you need to, and type backend in again. Then hit the escape key, and then type a colon. That's a shifted semicolon, 2 dots, one on top of the other. And that brought me right down to the bottom of the screen, and it's waiting for a command. I'm going to type WQ for write and quit. Okay, now if I ping backend, it actually returns localhost. That's all I have to do, okay? So that's exactly the same on Mac and Linux. Now, if you're on Windows, it's a little different, but it's pretty simple. So if you look at the course resources for this lecture, you'll find a link to this page. How to lock, manage, edit host file in Windows 11 and 10. And all of the instructions for doing it are right here, okay? So just read through this. It's very simple. You'll be able to find the file that you need to modify and making the change. And it has multiple approaches for doing it. But get an entry in there so that you have back end, all one word, all lowercase, pointed to localhost, okay? Once that's done, I should be able to go back now to Visual Studio Code, clear the screen in the terminal, make sure I'm in the project folder, and try bringing up Docker Swarm. First thing I'll do is I'll make sure that nothing is running. So I'll go to Docker Desktop, nothing is running in Docker. I'll go to my Docker Desktop dashboard and make sure nothing is running. And if it is, I'll bring it down, but it looks like I have nothing running. Perfect. So now I'll type docker stack deploy -c, and my stack file is called swarm.yml, and I'll give it a name, my app. And hopefully it'll all come up. Let's find out. And of course, I actually left the swarm at some point, so I have to type docker swarm init. Try that again. There we are. And now I'll hit the up arrow and get to my deploy, and we'll deploy our stack. Ignoring unsupported options, restart. I'll have to take that out of my swarm file after we're done here. Everything's coming up right now, so we can actually take it out while it's coming up. So I'll bring up my swarm file, and I will search for restart. There, so we'll get rid of that line entirely under Postgres. And hit Control G. That's the only entry. Perfect. So things appear to be running right now. Now let's go look at our Docker dashboard to make sure. Make sure everything came up. It looks like everything started without a problem. So now I should be able to go to my favorite web browser and just go to localhost. And there it is. It came up. This is really encouraging. However, not everything is going to work. I deliberately left one step out just to give you a bit of a challenge, okay? So this works just fine. So let's test the broker. And we get an error. Type error, network error when attempting to fetch resource. And there's a reason for that. If we actually view the source for this page, and we go down to the JavaScript section, here, every time I have a fetch statement, I'm calling http:// and then the slashes, and we're going to localhost port 8080. But of course, we're not listening on port 8080 anymore. That should say http:// then the funny slashes to make it work in a Go template, backend/handle. So we need to make a change to this particular file. And this will be the subject of a challenge that I will outline in the next lecture. So let's go on, and I'll go through the steps necessary for you to fix this particular problem. So we have a bit of a problem at the moment, and it's a very simple problem to demonstrate. In the front-end microservice, in the cmd/web/templates folder, we have this file, test.page.gohtml. And down in the JavaScript section of this particular file, anytime I make a call to fetch, I have a hard-coded URL. And right now it's going to localhost port 8080. And of course, we're not actually listening to port 8080 on localhost. We are listening on port 80. Well, we don't want to go to localhost 80 because that's actually the front end. That's what's displaying this page in the first place. We actually want to go to this URL, /backend. And of course, backend is what we set up in our hosts file just a lecture ago. Now we could, if we wanted to, go find every call to fetch and change the URL manually, and that would work, but it's only going to work for the short term. As soon as we go to deploy this microservice to an actual production server on the internet, that's going to have an entirely different URL. There's no way you're going to http://backend as an address. It's just not going to work. So it seems to me that this would be an ideal situation where I simply pass a value, pass some data consisting of the URL I want to this Go template. And that would make this ever so much more portable, particularly if I store that value in the environment. So in that case, if I want to deploy to a machine on the internet with a particular URL, I just set an environment variable in the Docker file or in the Swarm file or somewhere, read that from the environment, and pass that value to this template. And that is exactly what we're going to do. Now, once that's done, there's some other things we're going to have to do as well. We're going to have to build a new version of this Docker file. We're going to have to tag it and push it somewhere. And there might be some other changes that are required. And that I'm going to leave as an exercise for you, as a bit of a challenge. Now, don't worry. I'm going to help you through the first part here, where we're actually passing data to this template, because that's certainly not part of the core curriculum for this course. But the remainder of it, whatever steps are necessary to update our swarm, I'm going to ask you to do. And if you have problems, don't worry. I'll show you how I do it in the next lecture. But for right now, let's get started modifying this package, the front-end microservice, so we can pass some data to this template. And it's actually pretty easy. So to start with, I'm going to go over to main.go, the only Go file we have in this particular project. And at the bottom of this file, in this function render, what I'm going to do is actually get some value from the environment. I'm going to assume I'm going to put it in the environment somewhere, create the appropriate data structure, and pass that to the template. And it's really easy to do that. Down here, in the render function, the very last thing I do is I call template execute. And as you can see, this particular function takes two parameters. The first one is an IO writer, which we're satisfying with our response writer. And the second one is data any, and that is where we store data that we want to make available to the template. Now, there's a number of ways of doing this. You could pass a map, you could pass a slice, or you can pass a struct. Those are the three ways we pass data to a template. And I'm going to use a struct. So I'll create a variable, which I'll call data, and it's just a struct, and it has one member, and that member has to be exported, which means it has to start with a capital letter. So I'll call this broker URL, like that. And it's just a string, okay? Now I'll populate that field, data.brokerURL, by calling, straight from the standard library, os.getOnv. We'll get an environment variable. And I'm going to assume that this is going to be called broker_URL, like that. Okay, so now I have this data variable. Let's use it. I'll replace this nil with data. And that should be the only change I have to make to this particular file. Now, of course, we need to use that data that's being passed to the template. So over I go to test page go.html, and I'll find the first occurrence of fetch. And in my case, it's the function that's listening on the mail button. So mail button.addEventListener. So find a fetch statement. And what I'm going to do is replace this entire string with double curly brackets. And I want to pass just the URL, just http://backend. And I need to have /handle at the end of this. So I'll use the built-in template function, print, and I'm going to print the data passed to this variable, .broker_URL. And I want to append to that the string /handle, okay? And I have to do it this way, otherwise you're going to have overlapping quotation marks. Now I don't have to put quotation marks around this entire thing. Go is smart enough to say, hey, you're trying to print a string in a template in the JavaScript section, so I'm going to put quotation marks around it for you, and it'll do that. So I'll copy this because I'm going to have to use it in other places. And I will find my next fetch statement. So let's scroll down to the next fetch statement right here. Now this one's almost the same. This is going to a different URL. Well, I can just change it. So instead of going to /handle, I'm going to go to /log-gRPC. So I'm going to paste in what I copied and change this to log-gRPC. And let's keep going. And the next one is for the log button. And that one's just going to handle, so I can replace this with what's on my clipboard. And keep going. This one again for the authentication button. That one is just going to be replaced with what's on my clipboard. I think there's one more. Yeah, the broker button. And this one's really simple. It's just going to the actual address I'm receiving. So all I have to put in here is .broker_URL. Now, if I got everything right, if this is the actual variable I have, broker_URL, let's verify that by looking at main.go, and I'm passing it broker_URL, everything should work. Now, the remainder of the requirements to actually make this active, I'm leaving up to you. This is a challenge. And just as a reminder, you're going to have to at least build a new Docker image for the front end, tag it, push it up to Docker Hub, and anything else that you think might be required. And I'll show you how I solve that particular issue in the next lecture. So how did you make out with the challenge? I suspect you found it fairly simple. In any case, here's what I did. So, very first thing I did was in my project folder, I typed make build_front_Linux. And that, of course, builds the new version of the front-end application binary. And this is a step that people tend to forget now and again. And it's a moderately important one. So once that was built, I went up and then into the front-end folder. And I built and tagged a new Docker image. And I'll just hit the up arrow. And it was this one. So I built using the front-end Docker file and tagging it as tsolr/frontend:1.0.1 space dot. And that built the new image for me. And once it built, I executed the Docker push command and pushed that tagged version up to Docker Hub. So if you look over on Docker Hub, I now have version 1.00 and the one I just pushed up a little while ago. Okay, so that was up there. So that was easy. And of course, the last step was we need to take care of changing the Docker swarm file, swarm.yml, in the project folder. The first thing I had to do was change the tag for front end from 1.0.0 to 1.0.1. And then I had to add this section, the environment variable, which had to be called exactly broker_URL in all caps, and I gave it the appropriate value, http://backend. Then I brought up my Docker Swarm, and I have that running right now. So if I go back over to my browser and look at the version that's running here, when I click Test Broker, it works as expected. And that is pretty much all there is to it. Things work as expected. And the great thing about this is now, if I want to deploy this, when I want to deploy this on some actual servers that face the internet, I don't have to rebuild that Docker image and update the URLs in that one Go template for the front end. I just have to set an environment variable. And that makes it ever so much more portable. Okay, let's move on and start configuring some actual servers and try deploying an actual swarm on the internet itself. So an interesting thing happened after I deployed my Docker swarm to actual production servers, which you haven't done yet, but I was working ahead. So this is my swarm.yml file. And if I scroll down to the bottom of my swarm.yml file to the Postgres section, I'm actually importing the image for Postgres tagged at 14.0. And I'm going to strongly encourage you to change that to a 14.2. Okay? The reason being, after I deployed this to a couple of nodes up on Linode, I saw this, and I'll show you a screenshot I took. And you can see right here that for, well, hours, 100% of the CPU was taken by the node that had Postgres installed on it, and that's not good. So I did some research, and I discovered, and I'll take you to a web browser here, somebody else ran into this. And this process, kdevtemp.fsi process, is using 100% of CPU, and even if you kill it, it starts back up. It turns out, and this rarely happens with Postgres, actually it's the first time I've ever seen it, there was some malware in there, cryptocurrency mining software. So for about 8.5 or 9 hours, I was helping someone somewhere on the planet mine cryptocurrency, and that's not good. So I did what you always do when you have a compromised server. I completely just deleted that virtual private machine, reinstalled it, reconfigured it, and updated my swarm file. So just as a reminder, back in my IDE, make sure you're using Postgres 14.2. Now I did send a note off to the people that maintain the images, the Docker images for Postgres, warning them about this. And they pointed out that the tag 14.0 is no longer actually publicly advertised, but for some reason that image still had some malware in it. So hopefully they've resolved that. But in any case, please update that file. So we're finally at the point where we should be able to configure and deploy our swarm to actual servers. And of course, the first step in this process is determining what kind of servers do you want to use. Because with Docker Swarm, you can use a virtual private server, you can use a dedicated server, there's all sorts of options. But to keep things simple, what I'm going to do is look at a few different cloud providers that offer relatively low-cost hosting of virtual private servers. The one I'm going to go with is actually the one on the screen in front of us right now, and that's linode.com. They've been around since 2003, and they're quite cost effective. In fact, right now, as I record this, and it may not be the case when you take this lecture, but they actually have $100 credits. You can actually sign up and have $100 to play with, which is way more than you'll need to complete the requirements for this course. Of course, there's other options as well. DigitalOcean is very popular, and they work very well. I've used them. I continue to use them for some of my projects, and they have lots of options available. And another popular one is Vultr, which is also relatively cost effective. I actually think it's cheaper than the other two, but at the moment they're not offering any free credits to sign up. So I'm going to use Linode, and I already have an account on Linode, so I'll log in. And as you can see, I already have some servers up and running here, but I want to create 2 new ones. What I'm going to do is I'll create 2. And I'll go through the process of setting one up with you, and then I'll do the second one between lectures, because there's absolutely no point in you watching me do exactly the same thing 2 times in a row. So I'll create a Linode here, and I have to choose what kind do I want. Now, this is a course, and we don't need a really high capacity server, so I'm going to choose an operating system, and I suggest you follow right along with me, regardless as to what provider you're using. I'm going to choose Ubuntu, which is way down here, and I'm going to choose 20.04 LTS, the long-term release. And you can put it in whatever region you want, but make sure you put both of the servers. If you create 2, you can just do one if you want to, but if you create 2 like I'm going to, make sure you choose the same data center for both. Although you can create Docker swarms that live in different data centers, the various nodes, it's really not recommended because of network latency. So I'm going to put mine in Toronto because that's pretty close to where I am. And I'll go with shared CPU, and I'll just choose this $10 a month Linode that has 2 gigs of memory and it has 50 gigs of disk space, which is way more than I actually need, okay? I'll give it a label. Now, I suggest you name the first one you create node-1, just so you know what's going on, okay? So node-1, I'm not going to bother with any tags, and you can choose a root password. I happen to have private keys set up on mine, but choose a root password if you want to. And when you're done, you can come all the way down here and say create Linode. And it wants a root password when I'm deploying from an image. Since the last time I tried this, so I'll just put that in there. This is only going to live for the duration of the course, so I'll create it. Perfect, it's being provisioned, and I'll wait for that to happen. It only takes a minute or so. There, that's all provisioned. So now I'm going to go back over here to my Linodes, which is what they call them here. DigitalOcean calls them droplets, Linode calls them Linodes, and I have a node 1. Now I'm going to create another one that's exactly the same, okay? So again, I'll choose Ubuntu 20.04, and I'll choose the same region, and I'll choose the same size. And then down here, apparently I have to give it a password now, after I give it a label of node-2, and I'll put in a password, okay? Try that again. There, make sure I get it right. And I'll also put in my keys, and I will come down here and say create Linode 2. Okay, while that's spinning up, I'll end this lecture, and in the next lecture, as I say, I'll fully configure one of the servers. Then, when I'm finished recording that lecture, I'll configure the other one between lectures, because it's exactly the same steps. And after that's done, we'll get Docker Swarm up and running. So as I said last time around, what I want to do right now is to configure one server completely, to set up a non-user account, to enable a firewall, to install Docker, that sort of thing. And for this lecture and the next one, that's exactly what I'm going to do. Then, if you're using more than one node or more than one server in your Docker Swarm cluster, you just set up the remainder of the servers exactly the same way you do this one. Okay, so I'm going to do my node 1 first. And here I have a nice little thing I can copy that allows me to SSH into that server. So I'll copy that by clicking this button. Then I'll go to my terminal and I'll paste that in at the command line. SSH root at the IP address. And the very first time I connect, it says, "Are you sure you want to continue?" And I'll type yes. Now I'm in. So the first thing I'll do is I will add a user. So I'll add a user, and I'm going to call the user TCS, which is my initials, and I'll press enter, and I'll give it a password. So I'll type that once, and then I'll confirm it, and it asks me to enter name and all sorts of things. I'm just going to press enter for the default for all of these. Is the information correct? Yes, it is. Okay. Now I've created that user, and I want to give that user sudo privileges so that user can actually execute commands as root. And we do that by typing, and I'll clear the screen, usermod, USERMOD space, -a, lowercase, uppercase G, space, sudo, and then the username I just added, okay? So that's the command, and now that user exists. So I'll now be able to SSH into the server as that user with the password that I chose a moment ago, and I can execute commands by typing sudo. The next thing I'm going to do is I'm going to set up a basic firewall. And we do that in Ubuntu by using UFW, the uncomplicated firewall, and it's dead simple. First of all, I'm going to allow SSH, so I actually have a means of connecting to the server from the command line. So I add that. And then I'll allow UFW, allow HTTP, insecure web. And now we'll do the same thing, but I'll use HTTPS. Okay, so those are basic things. I can now SSH in past the firewall once I turn it on. And when the web server is running, we can connect using port 80 or port 443. But we're not finished. We need specific firewall ports to be open for Docker Swarm, okay? So let's do that. UFW, allow, the first one is port 2377. And make sure you type these right. And we're going to do that using /TCP. That's the port that the protocol we're going to allow. Okay, so that's added. Now we'll UFW allow, and this port is 7946/TCP. And then hit the up arrow and change the TCP to a UDP. It requires both protocols. Okay? And now we'll UFW allow, and this port is 4789/UDP. And one more, and this one's just so we can hit mailhog. UFW allow, and the port is 8025/TCP. Okay, now we enable the firewall, and make sure you have absolutely everything right. In particular, that first one, UFW allow SSH. Because if you don't have that right, and you type this command, UFW enable, then you're locked out of your server. And that's a bit of a pain, okay? So I'm going to enable it, and it asks me to confirm that, yes. And now if I go clear the screen and type UFW status, you can see my firewall is all set up for IP version 4 and IP version 6. Okay, so we have that in place. Now, let's copy this address up here one more time. And I'm going to leave this window open, and I'll open a new tab because I have tabs in my client. And I'll paste that command in, and then I'll backspace, get rid of root, and change that to the username I added, just to make sure I can connect as this user. And type in my password. And I'll clear the screen and type sudo ls. And it should ask me to enter my password. And there's nothing in that directory, but the command executed as expected. And that was executed as root. And that's what I wanted to confirm. Okay? Now, obviously, there are many more steps required if you want to make your servers absolutely secure. And DigitalOcean has a really good tutorial on hardening an Ubuntu 20.04 server. You might want to look for that. I also have a course on Udemy about securing VPS, and it happens to use Ubuntu 20.04 as the version. But in any case, that's beyond the scope of what I want to cover in this course. And for our purposes, we have a firewall in place, we have secure user accounts, and if you chose good passwords, you'll be fine for the duration of this course. Okay? So, in the next lecture, we'll install Docker on this machine. So the next step in this process is to install Docker on our servers. And the instructions for doing that are right here on Docker's documentation, docs.docker.com, and there's a link to this in the course resources for this lecture. And if you scroll up at the top, you'll see that there's a number of ways of doing this. But the one that's recommended, and the one I'm going to use, is to install the Docker repository and then install Docker from that. So let's do that. So I'll go over to my terminal. So I'll connect to my server, SSH TCS, which of course is my username, and you'll use your own, at whatever IP address your server is. So I connect, type in my password, and the first thing we have to do, according to the documentation here, is sudo apt-get update. So on Ubuntu, just sudo apt-update is sufficient. Type in your sudo password, which is your user password, and then we'll go and update all these things. And it says 73 packages can be upgraded. So what you're going to want to do, of course, is sudo apt upgrade. But I'm not going to do that right now. I'll do it after the lecture is over, just because it'll take a while and there's no point in you watching that happen. But in any case, the next step here is to do this. So I'll copy this right from the instructions and go back to my browser or my terminal and clear the screen and just paste that in and hit return. Okay, so that's already the newest version. Perfect. And the next step is this one. So I'll copy this entire instruction, add Docker's official GPG key. So I'll copy all of that, go back to my terminal, paste that in, and that will download a file and then install it. Okay, so we've added the necessary keys. Now the following command is to get the stable repository, and that's what I want. Okay, so I'll copy all of this and paste it in and hit return. And that's done. And now we install the Docker engine. So I'm going to have to do the sudo apt update and then this command. So I'll copy the second command. Go back to my terminal, do a sudo apt update. And then I'll paste in the command I just copied, which should install docker CE, docker CE CLI, and containerd.io. And I'll say, yes, I do want to continue. And in a moment, it should all be installed. So that should be done. So I'm going to clear the screen and type which Docker. And there it is. The Docker command is now available to us. So I have Docker installed. And of course, you'll have to install it on your other server or servers if you're using more than one. But that gets us going. All right, let's move on. So we have Docker installed. And as you can see, between the last lecture and this one, I ran sudo apt upgrade just to upgrade all the installed packages. And then I rebooted the server because it actually updated the kernel. So there's only a few steps left before we can try actually deploying our Docker swarm to our server cluster. And the first thing I want to do, and I'm on my node 1, and I'm going to clear the screen, is I'm going to set the host name for this machine. And I'm going to name it node-1. And of course, if you have another server, node 2, you're going to want to name it node-2. And that's pretty simple. I'll type sudo hostnamectl, all one word, space set-hostname, space, and then the name I want. And I want to call this one node-1. Now, a word of caution, make sure you're on the right server before you do this. You don't want to name node 1 node 2 or vice versa. So I'll do that and type in my sudo password. And nothing appears to have happened. But if I log out, I just type exit, okay? And then I reconnect. I just hit the up arrow and I reconnect to node 1. Now, once I log in, you notice that the prompt up here, just before I logged out, says TCS, which is my username, at localhost. But now, when I log back in, it's TCS at node-1. Okay, so we've set the host name, and that's pretty important so Docker can find the appropriate servers. Now I'll clear the screen, and the next step is to put a couple of entries in my hosts file, just like we did when we set the hosts file on our local development machine. We're going to do the same thing here, but we're going to put one entry for each of our servers. So I'll type sudo vi/etc/hosts, okay, plural, and hit enter, and type in my sudo password. And now at the bottom here, I'm going to hit the lowercase o to get a blank line. Then I'll hit return again. And I'm going to put in the IP address of this machine. Now I'll go back to Linode and I'll find node 1. And over here is the IP address. So I'll copy that by clicking that button, go back to my terminal, paste it in, hit tab, and type node-1. Then I'll hit return. Then I'll go back to this screen, and since I'm doing 2 servers, I have a second one I have to put in there. So I'll copy the IP address of the second server, go back to my terminal, paste that in, hit tab, and this one's going to be called node-2. And this is pretty important. It actually makes things a lot faster because it doesn't have to do DNS lookups, and if the name server disappears for whatever reason, things will still work. It's always good practice to do this. Now that I'm finished, I'll hit the escape key to get out of my entry mode, type a colon to get into command mode, and type WQ. And that's it. That's all I have to do for that. Okay, now make sure you do the same thing on your other server or servers if you have more than one. And in the next lecture, we'll actually put some DNS entries in for the machines in question. Now this presupposes that you own a domain name. And if you don't have one, don't worry about it. You can just follow along with me. And at some point when you have a domain name, you can go do the necessary name server entries. Okay? So let's move on in the next lecture and set up our name server entries. So we're getting closer to the point where we can actually deploy our swarm. And the next step, for me at least, is to set up some name server entries. So right now I'm on GoDaddy.com and I have a domain I've purchased there called learn-code.ca, and everything I'm going to do in this lecture is specific to that domain. Now, if you have your own domain, you can follow along, but make sure you don't use learn-code.ca, use your own domain. Now, I'm logged into GoDaddy right now, and over in another tab in my browser, I'm listing all the linodes that I have. This way I have easy access to the IP addresses, okay? So I'm going to go back to GoDaddy, and I'll go to my account because I'm logged in, and I'll choose My Products. And that takes me to this account management screen. And GoDaddy changes this screen periodically, so it might look a little bit different if you're using GoDaddy and you get there. But this is my domain, learn-code.ca, and I'm going to click on the DNS button, okay? Because I'm managing my DNS up on GoDaddy. And this is probably the only domain for which I'm doing this. I actually run my own name servers because I'm a bit of a control freak, but a lot of people don't do that, and a lot of people use GoDaddy, so I figured this was the easiest approach. So what I want to do here is I want to click on the Add button. These are all of the existing entries for my name server, okay? And GoDaddy does make this pretty easy. I'll click Add, and I want to choose a type. And the first one I'm going to choose is A. And the name is going to be, for GoDaddy, I'm just going to put node-1. And the value has to be a valid IP4 address. Okay, so I'll go back to Linode and find the IP address for this particular node, node 1. I'll copy that. And I'll go back over to my domain manager and paste that in here, okay? And I'll leave the time to life as default. So I'll add that record. And it's updating it, and it's done. Now I'll add another one, and obviously this is going to be another A record, but this time it's for node-2. And I'll go get the IP address for node 2 right here and copy that, and go back to the domain manager, and then I'll paste that in, okay? And again, I'll leave the time to life to default. You can set it to whatever is appropriate for your needs, and I'll add that record. Now I'll add another A record, and I could use a CNAME record, but I'm going to add an A record, okay? And I'm going to use the same IP address I have for node 1. So I'll click Add, and I could use www, but I'm pretty sure I'm using that somewhere else. So I'll make this an A record, and I'll put in just swarm. And I'm going to hit my Docker swarm by going to swarm.learncode.ca or learn-code.ca, okay? So swarm is the name, and I need the IP address of node 1, which I have right here. So I'll copy that, and I'll paste it in, okay? And I'll add that, and see if it lets me do this. And it did. Now, this is going to seem odd, but I'm going to add another A record for swarm. So add another A record. This is an A record. It's swarm again, but this time I'm going to copy the IP address for node 2. And I'll add that. Okay, now why did I add 2 A records with 2 separate IP addresses? Well, when we actually go to deploy our Docker swarm, we'll be able to go to any node in that swarm using the address swarm.learn-code.ca in my case. And even if the web server is running on a different node, it will still bring the application up. And this is one of the nice features about Docker Swarm, is that I can hit anything in the swarm, any node in the swarm, and it's just like hitting a node that has the service that I want. So in our case, we'll be running only one instance of Caddy at our web server. And even if it's running on node 1, which it will be, you'll see that when we actually set up Caddy on this cluster of servers, even if my request goes to node 2, I'm still going to have access to Caddy. And that's one of the cool things about this. Okay, so that's all set up. Now, a word of caution. Some name servers can be relatively slow to update. GoDaddy, in my experience, on the rare occasions when I use it, it's actually pretty fast. But you might have to wait a few hours before the name server changes actually take effect. Now, you can verify it by opening up your terminal or your command prompt on Windows. Make sure you're not logged into your server. So I'm on my local machine right now. And if I ping swarm.learn-code.ca, and it's been, 2 minutes since I made that entry? Let's see if this works yet. And it does. So GoDaddy updated very, very quickly. And the same thing would be true for node-1 and node-2. But in any case, now I have everything configured on my servers, enough for the purposes of this course in any case. I have Docker installed on both of my servers. I set up the host names on both of my servers. I've made the appropriate entries in my /etc/host files on all the servers. And now I've set up the DNS entries pointing to those servers. So we're finally at the point where we can start trying to get our swarm up and running on both of our servers. And if you're using just one, just do it for one server. But I happen to be using two, so we'll do at least two in this course. All right, let's move on. So in the last lecture, when I said that we had everything set up in our domain, I may have spoken too soon. I actually did add the necessary records for Node 1 and Node 2, and that's just for my purposes. We don't actually need those, but it's good to have them set up properly. We also added two A records for the swarm, and one points to one node and one points to the other node, and that's good. But of course, we also need one to connect to the broker service itself. The front-end application, which I'm going to hit by going to swarm.learn-code.ca in my case, it actually makes fetch requests to a domain at the back end. And that, of course, is something I need to configure. So that's really simple. I'll just add, and this time I'll just use a CNAME record, which is an alias. And I'm going to call mine broker. I'm going to go to broker.learn-code.ca. That's where I'm going to make my fetch requests. And you can call yours whatever you want. And it has to go somewhere. And it has to go to swarm.learn-code.ca. And I'll use the default time to life. Okay? So let's add that. And it's updating. And in a few minutes, once the time to life is passed, that should be available. Okay, sorry about that. That was an oversight on my part. Okay, so it's time to initialize our Docker swarm. And right now I have two terminal windows open. The one on the left, as you can see, is connected to Node 1 with my non-root user account. And the one on the right is connected to Node 2, again with my non-root user account. So, to initialize our Docker swarm, all we should have to do is type docker swarm init. And then I'm going to add something here because we're not working on a single node swarm as we were locally. I'm going to add --advertise -addr, and then I'll put the IP address of node 1. And as you can see, in the browser window behind this, I have my list of linodes with the IP address displayed there. So all I have to put is the IP address of node 1, which is 172.105.9.26. Now, I'm running this as a non-root user, so I'm going to go right back to the very beginning by hitting Control-A and add a sudo in front of that, okay? Otherwise, it just won't work. So this will now execute the docker swarm init --advertise address with my IP address. And of course, you're going to use your own IP address when you execute this command. It'll execute that as root. I type in my password for my non-root user account. And there I get this information. Now, this is what I want to pay attention to. I'm going to copy this docker swarm join, that entire thing, which is on 2 lines. Then I'll go over to my Node 2 window, and I'll type sudo and paste in what I just copied, okay? And type in my sudo password. And at that point, I now have initialized a Docker swarm with one manager node on Node 1 and one worker node in Node 2, okay? Now there's nothing running right now. I can go back to this window and type sudo docker service ls. And there's nothing there because we haven't deployed anything yet. So now we need to take the steps necessary to get our Docker swarm file and our image for Caddy ready for deployment to a production server. And we'll get started on that in the next lecture. So we're almost ready to deploy our swarm to our actual servers, but there's a couple of steps we have to take first. To start with, here in the project folder, in the file named Caddy Docker file. Okay, so this Docker file actually creates an image, which is basically a clone of Caddy version 2.4.6-Alpine, and it copies in this Caddy file, and that's the problem. If we look at the Caddy file right here, this is referring to localhost port 80 and backend port 80. And that's just not going to work, okay? So I'm going to copy all of this. And what I'll do is create a new file called caddyfile.production, okay? And then I'll paste the contents in there. And we'll modify this so it'll actually work on our cluster. So we're not going to go to localhost. If you recall, I actually called mine swarm.learn-code.ca. And I am going to leave the :80 there for right now. If I took it out, when we deploy this, it would try to fetch an SSL certificate. And I want to make sure everything works before I actually bother installing SSL. So that's the first change I have to make. And the second one, of course, is we're not going to backend 80. We're going to, I called mine, broker.learn-code.ca. Okay? And again, I'll leave that at port 80. Nothing else should change. Now, I'll open up the Docker file, the caddy.docker file, select all and copy, close that, create a new file here in the project folder, which I'll call caddy.production.docker file. And I'll paste in the contents I just copied, but I'll just change this one line. Instead of copying caddy file to this location, I'll copy caddyfile.production. Okay? Now I'll open my terminal window, get into the project folder, and I'll say docker build -f, and I'm going to build caddy.production.docker file. And I'm going to tag it with tsolr / and I called my other one microcaddy. So I'll call this one micro-caddy-production. And you can use whatever name you want. And I will tag this as version 1.0.0 and hit a dot. Okay, so we're going to build that Docker file. And now I'll push it up. Docker push tsolr / and again, I named mine micro-caddy-production : 1.0.0. And that should push it up to Docker for me. Docker Hub. Okay, so that's done. Now, just as I created a copy of my Docker file and the appropriate caddy file for caddy, I'm going to do the same thing with swarm.yml. I'll open that, select all and copy, and I'll create a new file in the project folder called swarm.production.yml. And I'll paste in what I just copied, go to the very top, and I'll change this from tsolr micro-caddy to micro-caddy-production. Okay? And everything else there should stay the same. Now, are there any other changes I have to make before I deploy this? Let's go down to the volume section and have a look. I think that'll be okay. All I'll have to remember, if I leave it like this, is that when I deploy the stack, when I use that docker stack deploy command on the production servers, I'll have to do it in the same folder where these folders exist, which means I need to go create them. So let's go over to our terminal. And I'm still in node 1. So what I'm going to do is I'll go to the root level. Okay, so I'm at the root level of this server, and I'll type sudo makedir swarm. I'll create a directory, and I have to do it using the sudo command because my user account doesn't have permissions. I'll create a directory named swarm right at the top level of my server, and you can put yours wherever you want. Okay, and I'll type in my password, and then I'll type sudo chown, and I'll use my user account : my user account again. I'll change the ownership of the swarm directory to this user account. It just makes things simpler. Now I'll go into the swarm account, cd swarm, the swarm folder, and I'll create 2 new directories. Let me just move this window over so I get the names correct, okay? Makedir caddy_data and makedir caddy_config. Okay, so now those directories exist. Now I need my swarm file, so I'll just create a new file, vi swarm.yml, and then I'll go back over here to get my swarm.production.yml, and make sure you get the right one, select all and copy, go back to my terminal, and I'll hit I to get to insert mode, and then I'll just paste in the contents. Hit escape, : WQ, return. Okay, So at this point, I now have the swarm file necessary to deploy the stack or deploy the swarm. I have the 2 necessary directories created, and I'm relatively certain that I don't have to do anything else. So let's try deploying this. And we know how to do that. So you have to be in this directory, in the swarm directory I just created. So I am. There's my swarm.yml file. And I type docker stack deploy -c for configuration. And I'm going to use swarm.yml. And I'm going to give it a name. And again, I'll call it my app. Doesn't matter what I call it. Let's see if this works. Of course, I ran that as a non-root user. So hit the up arrow, Control A to get to the start of the line, and type sudo. Put a sudo in front of that. And it's creating them. Now, of course, it's creating a version of our database that doesn't have anything in it. That's not a big deal. I just want to make sure this actually runs. I know that when there's valid information in the database, it actually does what it's supposed to. I just want to get the swarm up and running. And I'll show you how to connect to the database using SSH in a bit. But for right now, it appears to be started. Now I'm going to give it some time to actually bring everything up, because it takes a while to initialize the database first time around. But in a couple of minutes, we should be able to hit our swarm using a web browser. So we'll try that in the next lecture. So we have our swarm up and running, and now we want to try things out. And I should give you a word of caution. There are a couple of deliberate errors I put in there just to emphasize how difficult it can be to deploy and manage a distributed application. And there's another mistake that was there just because I forgot to do something, which I do sometimes. But in any case, let's give it a try. So I'm going to go over to my web browser, and I'm going to go to the host that I specified, which is swarm.learn-code.ca. And it came up. That's really encouraging. That means at least the swarm is running, and at least the caddy microservice and the front-end microservice are doing their thing. So that's encouraging. So let's try clicking test broker, and it's not going to work. And this is because of the thing that I actually forgot to do. So we click that, and it says error, network error when attempting to fetch resource. And there's a really simple explanation for that. So let's go back over to our IDE. And let's have a look at the file, swarm.production.yml. And if you scroll down to the front end part, you remember that environment variable we set up that goes to back end? Well, of course, we're not going to back end. And I forgot to change this. And in my case, it has to go to broker.learn-code.ca. That's the first problem. Now we could put the new version up there and delete the Docker swarm and start it back up, and hopefully it would work, but it's actually not going to. And there's a reason for that. Let's go back to our terminal. Now I'm still logged into my first node, node 1, which is the manager node, and I'm still inside the swarm directory. And the first thing I'm going to do before I forget is add myself, my user account, to the Docker group, just so I don't have to keep typing sudo every time I execute a command for Docker. And I'm going to do that by typing sudo usermod -a uppercase G space Docker, and then the user account I want to add to the Docker group, and that's TCS. And once I enter in my password here, now I should be able to type docker service ls without the sudo. And I can. And you'll see a few things that look a little bit odd here right now. No problem, it seems like the authentication service started up, it seems like the broker service is going, those are all 1 for 1. But if you go down to Mailhog, that has 2 out of 2, and Mongo has 0 out of 0. And Postgres has 0 out of 1. So there's something not working properly there. And it's actually pretty easy to explain. There's another command we can run here. And I'm going to type it like this. Docker node ps. And that gives me information about the nodes and the services running on them. And it looks like right now everything is running on node 1, which is not unusual when you first start up a swarm like this. Things will get pushed around as necessary. But some of these got rejected. So, for example, the Mongo app got rejected. It says invalid mount config for type. And the same thing for Postgres, invalid mount config for type. And of course, that's because if you go back to our swarm.production.yml file and go all the way down to Mongo and Postgres, these expect to find a folder named dbdata and then one called Mongo inside of it. and a folder called dbdata and one called Postgres inside of it. Well, we can fix that easy enough. Make sure you're inside the swarm directory and just make dir, and we're going to call it db-data. Okay? And then I'll hit the up arrow and put /mongo to create a Mongo directory inside of that. Then I'll hit the up arrow and backspace over that and put /postgres at the end. Okay? So we may as well stop our Docker stack right now because it's not running properly. So I'll shut it down with docker stack rm, and I called it my app, and that will delete everything. So they'll go away momentarily. But there's other problems here as well. Notice that if I scroll up, I should be able to see it right here. We have that keyword global tied to Mailhog and Mongo and to RabbitMQ. Now let's go back over here and find out where they are. I'm just going to search for the word global. Okay, so there's at least 3. One for RabbitMQ. And when we were running on our local development environment, that global keyword worked just fine. What that means, apparently, is keep one instance of this service running on every node of the swarm. And that's not what I want. I actually want this to be replicated now. And I want it to be replicas 1. I'm going to copy that. And I'm going to paste it for Mailhog. And I'll also paste it for Mongo. Okay? And down here, I have Postgres replicated 1, so that's fine. So there should be no more occurrences of global, and there's not. That solves that problem. Now, the other problem we're going to run into is we tied this volume, the local folder on the server, db-data /mongo, to the folder /data/db in the container. And that'll work just fine, unless Mongo gets moved at some point to a different node, one that doesn't have that directory, okay? And that would be problematic. So how do we fix that? What we can do is add another directive to the deploy part here, and we'll have to do it for Mongo, and we'll have to do it for Postgres, okay, initially. What we can do is we can add another keyword here, placement, which I have to spell right, colon, return, and then a tab, and then constraints, and then a colon, and a return, and a tab, and a dash, and a space. And we can say node.hostname, and I'll make that equal to node-1, which is what I named my host in the host file for node 1. And node 1 is where that db data directory exists. So now I can copy this and find Postgres and paste it right here as well. Okay, so that'll be on node 1. So that's for Mongo and Postgres. Now, ultimately, when we deploy this, Caddy with its secure SSL certificates enabled, we're going to do the same thing there. So we might as well do it right now. Paste that in there. Okay. So let's try this one more time. See if we got everything right on the second try. So I selected all and copied from my swarm.production.yml. And I'll go back to my terminal and clear the screen and do an ls. There's my swarm.yml. So I'll just rm swarm.yml to delete that version. Then I'll type vi swarm.yml to create a new version. It's currently empty. Hit I to get in the insert mode. Paste in what I just copied. Hit escape to get out of insert mode. Then a colon, WQ, return. Okay? Now nothing should be running in Docker right now. So Docker service ls. And there's not. So let's deploy our stack again. Docker stack deploy -c swarm.yml, and again I'll call it my app and hit return. And I have a problem here somewhere. YAML line 12 did not find expected dash indicator. Okay, so I got something wrong. And I have this in the wrong spot. Cut it out of there. That was a mistake. And paste it right here. And that's better. Select all, copy, go back, try this one more time. So we'll rm swarm.yml, vi swarm.yml, hit return, insert with an I, paste, escape, :WQ. And see if we have it right this time. Perhaps the third time is the charm. And everything seems to be spinning up. Now, to watch this, I'm going to type watch docker node ps. And it will actually show me an update in real time. I'm just going to watch this and make sure there's no errors appearing. And when I'm done, I'll hit Control-C to get out of it. So far, so good. So we have Rabbit, Postgres, Mongo, Caddy, Broker, Authentication. Those ones seem to be starting out all right. So let's do a Control-C to get out of this and clear, and do a Docker service ls. Okay, everything seems to be running. That's good. And as you noticed, when I did the docker node ps, these are the ones running on this node, which presumably means the other ones are running on the other node, which is really encouraging. Okay, so let's now go back to our web browser and reload this page to make sure it shows up. And it does. And let's try testing the broker. And we hit the broker. Now, testing authentication should work, but it should say you can't authenticate, because remember that the Postgres database up there is actually empty, and we'll put something in it momentarily. Let's try the log service. Okay, that worked. Let's try mail. And that worked. And let's try the gRPC log. And that worked. Okay. So the problem we have with the test authentication, of course, is that it doesn't even have a table in the database. So it's just giving me an error. So we'll have to populate that with a copy of our existing database just to make sure that it works. And we'll take care of that in the next lecture. And then we'll try enabling SSL and see if we can get our certificates automatically delivered to our caddy by Let's Encrypt. All right, let's move on. So this is just a quick lecture to show you how to connect to Postgres running in Docker Swarm. And as I said a while ago, I almost never do this. I almost never run a database in a Swarm or even in Kubernetes. Instead, I connect to some remote service. But we want to make sure that things work, and it's pretty simple. So I just started up Beekeeper Studio, which we haven't used for quite a while, and I'm creating a new connection. And I'll choose Postgres as the connection type. And I'm going to leave the connection type as Postgres. My host can't be localhost. It needs to be 127.0.0.1. And the port is 5432. I'm not going to enable SSL at all. My username is Postgres. My password is password. And the default database is users. And I will turn on SSH tunnel. Okay? Because remember, we're exposing port 5432 from our Docker Swarm. We're just blocking it using our firewall. So my host name, in my case, I'm going to use node-1.learn-code.ca. Port 22 is correct. There is no bastion or jump host. I'm going to use a username and password to connect. And my username is TCS, and I'll just type in my password here. And I'll test it. Click test. And it says the connection looks good, so I will connect. Now, I'm connected, and I'm in the database users, so I have an open query window, and all I'm going to do is, you remember a long time ago, I got you to download a zip file that was SQL statements that creates our user database. Well, I have that already on my clipboard, so I'm going to paste it in. And in case you lost it, I added it as a downloadable resource in this lecture. And then I just run this. And it ran with no problem. So now I have a users table. And inside of it, I have one entry. So now I can come back here, and I'll just reload this to make sure I left that running. I did. I'm back in my web browser. I'm on swarm.learn-code.ca, and of course, you're going to your own URL. And now when I test authentication, it authenticated. So that works well. Okay? Pretty straightforward. So in the next lecture, the final step in this process with Docker Swarm is to enable SSL certificates with our web front end, Caddy, okay? We'll take care of that in the next lecture. So the next step is to modify things so that our front-end web server, Caddy, listens on port 443 with SSL certificates. And of course, one of the great things about Caddy is it goes and gets those certificates for us. It updates them when they need to be updated and all that sort of thing. So I'm looking at the file swarm.production.yml. And as you can see right here at the top where I have my Caddy service, I'm already listening to port 443. And I already have mounted volumes to store the SSL certificates, which is caddy_data and caddy_config. So if I look over on my terminal, on node 1, inside the swarm folder, I have those two folders, okay? So what do we have to do? Well, to start with, we're going to want to update the front end here, this microservice, because that'll be going to an HTTPS connection. So I'll just add an S there. That's easy enough, okay? Now, are there any other changes I need to make in this swarm file? Well, ultimately, we're going to have to tag and push a new version of this to 1.0.1. So I'll change that right now. It doesn't exist yet, but we'll make it in a minute. And let's just go have a look at everything else here. As far as I can tell, there's nothing else we need to do with this file. So I'll need to have that up there. So I'm going to select all and copy this. And I'll switch back to my terminal. And I'll do an ls again. There's the swarm.yml. I'll just delete that. rm swarm.yml. And then I'll vi a new swarm.yml. I'm creating a new text file with the same name. And I'll hit I to get it in insert mode. And then I'll paste everything in. Hit escape to get out of insert mode. Type a colon to get into command mode. Type W for write, Q for quit, and hit enter. And now I have a new version up there. But of course we can't use that until we update our Docker image for micro-caddy production to 1.0.1. So let's do that. Now, what changes do we need to make for this? Well, if we look at the file, caddy file production, okay? This file right here, this is the one that's copied into that Docker image. And to make this work, I'm going to delete :80 for my first virtual host, okay? And now that it's going to be using SSL, I'm actually going to import security as well, this bit, which just makes sure that things work well. So I'll import security. That nothing else there needs to change. And then of course, for the broker service, I'll delete the :80 there as well. And this tells Caddy, hey, we're going to be using auto-generated and auto-managed SSL certificates. Now I'll open my terminal window and I'll go into the project folder if I'm not there already, and I am. And I just need to build a new Docker image and push it up to Docker Hub. So I'll clear the screen. So I'll type docker build, and I'm going to use the configuration file, the Docker file of caddy.production.docker file, and I want to tag it as tsolr/micro-caddy-production at version 1.0.1, and then a space and a dot. And now I'll just push that up to Docker Hub. Docker push tsolr/micro-caddy-production :1.0.1. There, that's pushed. Now I can go back over to my terminal and clear the screen. Now I want to update Caddy, okay? I want to update the Caddy microservice. And the first thing I have to do, and this is a step a lot of people forget, is I need to do a Docker pull tsolr/ the service I just pushed up there, or the Docker file I just pushed up there. And I called mine micro-caddy-production :1.0.1, the new version I just pushed up there. And that pulls it, okay? So I have a new version of that. Now, I could, if I was just updating one service, do something like this. I could say Docker service scale. And what I'm going to do is scale the Caddy service so there's two instances of it. So I'll scale my app, which is the name of my deployment, _ Caddy, and make that equal to 2. So that will scale it up to 2 services. And after it's scaled it, then I update the image. So I can say now Docker service update, and I provide the image flag, -- image. Then I specify the image I want, tsolr/micro-caddy-production : 1.0.1, the new version, okay? And the service I want to scale is, of course, myapp_caddy. So that will update the services, both of them, one at a time. That way, I have virtually no downtime. Now, of course, that's great for updating an individual service. The problem we have in this case is that we actually modified our swarm deployment file over here. Let's have a look at that. My swarm deployment file now is swarm.production.yml. We actually made a change to an environment variable. So in this instance, what I'm going to do is actually bring this down. So I'll say docker stack rm, and I called it myapp. So that deletes everything. And I'll give it a couple of seconds to actually ensure that everything goes down. And then I deploy it again with the new swarm file. And this will update the environment variable. Okay. Now this is the sort of thing you're not going to do in the middle of the day. You'll do it late at night when nobody's on the server, and you might give people warning beforehand. But we're just in development right now. Nobody knows about my server, so I'm not terribly concerned. So that should be enough time. So let's deploy this. Docker stack deploy -c, and my configuration file is called, better spell deploy right. And my configuration file is swarm.yml, and I give it the name again of my app. And this should deploy everything. And once it's done, we'll have a look and see at what's running where. So I'll give that a couple of seconds. And if I do a docker service ls, it shows me that everything appears to be running, and there's one instance of everything. So now let's find out where they're running. So I'll type docker node ps. And this shows me on the current node, which is node 1, I have caddy, I have the listener, the logger, the mail, Mongo, and Postgres. And now if I do docker node ps node -2, what's running on node 2? And there, those are the things running on node 2. So everything appears to be running. It's been running for about 33 seconds or 36 seconds. So let's go to our web browser and see if this worked. So in my web browser, I'm now going to go to swarm.learn-code.ca. And there, if you look up here, we have a little lock. And if I click on that, it says site connection for swarm learn-code. It's secure connection. I click on it and it's verified by Let's Encrypt. Let's test the broker, make sure that's working. And we hit the broker. Authentication, everything is working exactly as expected. Now, the way that we've made this work is pretty effective. There's no problem with it whatsoever. But we do have one issue. And it's not something I'm going to address in this course, but I'll point you in the appropriate direction. If we go back to our IDE and we look at the way that we're managing, for example, caddy. As I said, we're doing the same thing we're doing in caddy with Postgres, keeping it on a particular node. Right here, in the caddy microservice, under the deploy section, we have placement constraints node hostname must be equal to node 1. And that ensures that caddy's always going to be deployed. Even if we have multiple instances, it will always be on node 1. And the reason, of course, is this bit here, volumes. We have two folders that caddy expects to find in order to use SSL certificates. caddy_data, which is mapped to /data, and caddy_config, which is mapped to /config. And that works really well, but it would be really nice if I could actually have that information, the data that's in those two directories, available on every volume. And if I could do that, then I'd actually be able to deploy my caddy microservice as many times as I want on any node that I wanted. And there's a couple of ways of doing that. Let me go back to my web browser. There's actually many ways of doing that, but I'll point you to a couple. So if I switch over to this window, here's the first one. This is called Gluster FS, which is an unusual name. And it is a scalable network file system. In effect, what it allows us to do, if you install Gluster on your master node and on all your worker nodes, and share a particular volume or disk directory from one node to the others, anytime a file goes into the directory on one node, it actually gets automatically copied to all nodes. And it's pretty easy to install. There's lots of tutorials out there, and it's definitely one approach. And an alternative approach would be to use this service, SSHFS. And there's links to both of these in the course resources for this lecture. This is an SSH file system. You can mount remote file systems over SSH. Now, in my experience, this one, SSHFS, is a little bit slower than this one, but everything's in the same data center, and we're not talking about copying huge amounts of data, so it's actually not that much different. And I think SSHFS is actually easier to install. So you might want to look at installing this sort of thing on all nodes or in your swarm, and it becomes a convenient way of sharing assets between volumes without having to do anything manually. All right? But in the interim, we have things up and running, and we have concluded our consideration of Swarm. And now it's time to move on to another version of a container orchestration system. One that's considerably more complex, but one that's very popular right now. And of course, that's Kubernetes. And we'll be looking at that in the next section. So in this section of the course, we're going to turn our attention to Kubernetes, an alternative container orchestration system, and one that's very popular, and one that's also, and you really need to be aware of this if you're a small development shop or a lone developer, somewhat complicated. It's a lot more work to deploy and manage a Kubernetes cluster than it is to manage a Docker swarm. But it works really well, and we're going to go through the steps necessary to bring up a simple version of a Kubernetes cluster in this section. So I'm looking at the website for Kubernetes right now, kubernetes.io. And at the very top, you're going to see this warning, and it causes a lot of people some consternation. It says, as of Kubernetes 1.24, which is coming out just in a couple of weeks as I record this, Docker shim will no longer be included in Kubernetes. Read the Docker shim removal fact to see what this means to you. And you might think that this means, oh no, I can't use Docker with Kubernetes anymore. And that's not true. You absolutely can. There have been some internal changes into the way that the Kubernetes source code works to remove something called Docker shim and replace it with something else. And unless you have an existing Kubernetes cluster, this really doesn't affect you at all. And even if you do have one, unless you're doing a very specific set of things, which are outlined in this link, the FAQ, then again, it doesn't affect you at all. And it's not going to stop us from bringing up a cluster in this section. Now we're going to be bringing up our Kubernetes cluster using Minikube, which is easy to install. It installs on Windows or Linux or Macintosh, and it will allow us to work with our cluster really easily in development, okay? And the other tool we're going to have is kubectl or kubectl. And again, it's easy to install this on Linux, Mac, or Windows. So in the next couple of lectures, we'll install the necessary software, and then we'll get started deploying a cluster on our local machine. Let's get started. So as I suggested in the last lecture, we're going to install a tool called Minikube, and it's available for Mac, OS, and Linux. And this is a little piece of software that allows us to set up a local Kubernetes cluster and manage it. And it's very simple to install. So let's have a look here on this site, and there's a link to this in the course resources for this lecture. Let's install it. So I'll go over here to getting started. And installation is just a matter of choosing the appropriate buttons. So if you're on Linux, you're going to choose Linux or Mac or Windows, whatever one's appropriate for your operating system. Now I'm on a Mac, and there are two choices for the Mac. x86-64, which is an Intel processor, or if you have one of the new Macs with Apple Silicon, you're going to choose ARM64. Now I'm on a Mac with an Intel processor, so I just click the appropriate buttons, and please choose stable for the release, not beta. And the installer type, you can either do a binary download, or if you're on a Mac, you get the option of using Homebrew. But I'll do the binary download. And of course, these links or the information down here will change depending upon what operating system you have. So I'll copy these two lines by clicking the copy button over here. Then I'll go to my terminal. And make sure when you open your terminal that you're on your Mac and not on one of the servers you deployed in the last section of the course. And just paste this information in and press enter. And there it goes. And eventually it will ask me to type my sudo password. And you type in the password you used to log into your Mac. And there it goes. Now it's installed, and that's all there is to it. So follow the instructions for your operating system, install Minikube, and let's move on. So now that we have Minikube installed, it's time to get kube control, okay? So there's a link to this page on the course resources for this lecture, and you're just going to follow the instructions for your operating system, Linux, Mac, and Windows. Okay? So to install that, I'm on a Mac, so I'll click on the Mac link. I'm going to install it using any number of ways. The easiest way for Mac users, I think, is this one right here. Install kube control binary with curl on Mac OS. And again, if you're on an Intel chip like I am, you're going to copy this, so I'll copy this. But if you're on Apple Silicon, the M1 chip or one of those, you use a slightly different one, this one right here. Okay, so I'm using this one, and I've already copied this, so I'll go to my terminal. And I'll paste in that link I just copied. Now, that put it in the current directory, which for me right now is my users directory, my home directory, /users/my username. And that's not where I want it. So if you keep going here, they probably tell me where to put it. Right here. Step number 3 is to make it executable. So I'll copy this, and go over here and paste it in. And step number 4 is to move it where it needs to be with the first command right here. And this is a sudo command, so it will ask me to type in my password. And then again, I have another sudo command that will change the ownership to root. So I'll copy this and paste it in, and we're good to go. Okay? And at this point, then step number 5, it says we can actually get our version. So I'll copy this command right here just to make sure it worked and paste it in. And there it is. Okay? So that's all set and ready to go. Now, if you're not on a Mac, if you're on Windows, for Linux it's almost identical. But if you're on Windows, of course, there's a couple of ways of doing it. You can download the binary, like they say right here, and follow these necessary steps. And of course, you'll have to pay attention to step number 3, append or prepend the kube control binary folder to your path environment variable, which isn't that difficult. Or you can use Chocolatey or Scoop. So, whatever approach you choose to use is entirely up to you, but get kube control installed and let's move on. So now that we have Minikube installed and we have kube control installed, let's try starting up a Kubernetes cluster. And the first thing I want you to verify is to go to your Docker dashboard and make sure that you have no containers running, just to start things in a pristine state. Okay, so if you have a swarm running or you have run Docker Compose, just bring those down and get it to the screen so it looks something like this. Then go to your terminal, and I'll use the terminal that's built into Visual Studio Code, and let's try bringing it up. And in my case, it's probably not going to work the first try. I'll type minikube start and then -- nodes equals 2. And as I said, this is an old Mac. It's about 7 years old, and I haven't run Kubernetes on it in a while, and chances are I have some old things sitting around. Let's see what happens. There, despite the fact that I have the latest version of Minikube and the latest version of kube control, I have this error, exiting due to K8's old unsupported, so on and so forth. And what I probably have to do is just type minikube, delete. And it should have deleted anything that was there. Now I'll try running again. Minikube start nodes equal 2 and see what happens. And now it's downloading the latest version of Kubernetes, 1.23.3 as I record this. And 1.24 is coming out in just a couple of weeks, but this is sufficient for our purposes, and 1.24 will work fine if that's what you're getting. So this will take a little while. So it has the base image down. Now it's creating a Docker container with 2 CPUs and 4 gigs of memory. Generate a new client cert. As I said, I was running Kubernetes on this in the past. We're almost there. And now it's starting the second node, the worker node. As you can see, it uses the same kind of principle with a master and a node or multiple nodes. And you can have multiple masters too, but in any case, we're having 2. which is absolutely sufficient for development purposes. Okay, so Kube control is now configured to use Minikube cluster and default namespace by default, which is exactly what I wanted to see. So I'm going to clear the terminal, and I'll type Minikube status. And that tells me that I have a control plane running, I have the host, the kubelet, all these things are up and running, and I also have a worker node, minikube-mo2. So at this point, we've initialized a Kubernetes cluster, but we haven't actually deployed anything to it, but it is up and running. And if I go back to my Docker desktop, you can see now I have 2 Docker images running, okay? And this is exactly where we need to be. So in the next lecture, we'll actually start working with this, interacting with it, and try to get some things up and running. So at this point, we have our cluster installed, and what I want to look at this time around is something called the Kubernetes dashboard. And fortunately, Minikube has that installed by default. Now, you might notice right here in the terminal that between the last lecture and this one, I actually executed the command right here, Minikube stop, and that powered everything off. And the reason I do that is that one of the irritating things about Minikube, at least on my computer, is that when my system goes to sleep, when I wake it back up, I actually have to restart everything because Minikube just won't come up. So before I finish for the day, I type Minikube stop, and when I come back, I just type Minikube start. And that brings it back up. And it just takes a moment. It's certainly faster than restarting my entire system and getting back to where I was before things stopped working. Okay, so now it's back up and running. Now, I'm going to clear the screen and I'm going to have a look at the Minikube dashboard. And I do it by typing this command. Minikube dashboard. And that fires up a web browser. And it shows me the Minikube or the Kubernetes dashboard. Now, as you can see right now, at this point, we have nothing running. But as time goes on, and when we start deploying some services or deploying pods, as they're called in the Kubernetes world, this will update in real time. And there are all kinds of things you can configure here. And we can actually use the dashboard to scale services, to add services, things like that. But for right now, we have it up and running. So this is available to me as long as that command is still running. So if I go back to Visual Studio Code, this is still running. The minute I stop this by typing Control-C, now it's not available anymore. So if I went back to my browser and tried to do something, I would get an error, okay? But in any case, that's how you start the dashboard, and that's one suggestion about how you can avoid having Minikube simply lose connectivity after your system goes to sleep. Just Minikube stop before you're done, and Minikube start when you bring things back up, okay? So let's move on and start the process of defining some deployment files for Kubernetes. So let's look at how we write deployment files. And one of the things I want to make sure you have running right now is Minikube. So if I type Minikube status, and I'm sure you do, but as you can see, I have Minikube running. And if you don't, just type Minikube start and hit return and wait for it to come up, okay? Because we're going to be using this before too long. So since I have my cluster running, right now, if I type this command, kubecontrol get pods. Now, what is a pod? When we were working with Docker Swarm, the way that Swarm works is that you deploy one or more containers to the swarm. And in Kubernetes, it's not quite the same. Instead of deploying containers, we deploy pods. And a pod can have one or more container in it, and a pod can also have one or more service in it. So the basic unit within a Docker Swarm is a container, in our case, Docker containers. But in Kubernetes, the basic unit in a Kubernetes cluster is actually called a pod. So if I type kubecontrol get pods and hit return, you'll see that I have no resources in the default namespace. In other words, there's no pods there. Now, if I hit the up arrow and hit space dash capital A for all, and hit return, you'll see there actually are things running. But those are the basic components that make Kubernetes available to us in the first place. And what we want to do, before too long, is when I execute this command, I want to see something in that default namespace. I want to see a pod in there. But before we can do that, we actually have to define what that pod consists of, okay? Now there are two ways of doing this in the Kubernetes world. There's the imperative way, where we actually just type commands right at the command line using kube control and define our various pods. And that works, and you can certainly do that to make changes to an existing cluster, and lots of people do. I do all the time. But the other method is called the declarative method, where we actually create some files that have all the necessary commands or descriptors that describe what our resources are going to be, and then we deploy that file using kube control. And that's the most common way and the most sensible way, and the one that's less error prone. So that's what we're going to do. So to get started, I'm going to close this terminal window. And over in my project folder, it doesn't matter where you put this, but I like to keep things all together. I'm going to create a new folder in the project folder, and I'm going to call it K8s, which is the shorthand for Kubernetes. Okay? And there's a reason for that. If you actually count the number of letters in the word Kubernetes, you'll see why 8 is between K and S. Okay? Also, it's a lot easier to type. So inside the K8s folder, I'm going to create a deployment file. And I'm going to, first of all, just to make things easy, I'm going to deploy Mongo. So I'll create a new file in there called mongo.yml for YAML. Okay? So just like Docker Swarm did, we're going to use YAML files to describe our services or our resources in Kubernetes. And when we deploy this file, this YAML is actually converted by kube control into JSON, but it's a lot easier to write YAML. So we start with a description or an entry called API and then a capital V for version. API version, space, and we'll call this apps/v1, okay? And you'll see that on pretty much every deployment file out there, some variation of this. And what kind is this file? Well, space, and then with a capital D, deployment. We're deploying a resource, okay? And then we have some metadata, which is just descriptive, space tab, and the name for this is Mongo, because I'm going to be deploying Mongo. And again, in production, I would never put Mongo in a Kubernetes cluster. Instead, I would have a Mongo service running external to Kubernetes and connect to that. But we just want to get this up and running and see how things work. So this is fine for our purposes. Then we go back right to the left margin again, and we type the specification, spec, space, or return tab. How many replicas of this do I want? Well, you never want to have more than one replica of Mongo running if we're going to run it this way. So replicas, 1, return. Then we have to have some means of referring to this resource or this service when we need to, okay? So we'll give it a selector, return tab. Then match labels. How do I find this? We're going to match it using labels, return tab, and the app is called Mongo, okay? Then backspace to the same level as selector. So you're directly under the S in selector, and we describe the template for this resource. Template, return, and then again some metadata, which is really useful and makes it easy for us to see what's going on. Metadata, return, tab, labels, return, tab. I've got to spell labels right or nothing's going to work. Labels, that's better, okay? And then tab in once from labels and give it app Mongo. I'm consistent. I usually use the same name for everything in a given pod, okay? Then we're going to backspace to directly under the M in metadata, and we give the specification for this, okay? So spec again, return, tab, what containers exist in this particular pod, so return. And now, this is going to seem odd to you because in a lot of cases, editors for YAML editors will want to tab things in a little bit, but the dash has to appear directly under the C in containers. Okay, so dash and tabs really, really matter in YAML. Tabs and spaces and indentations, so pay close attention to that. So in this case, the name of this container is going to be Mongo, and I'll hit return. And now I want to be directly under the N in name and give this an image. And the image is exactly the same one we used over in Docker Swarm, Mongo, M-O-N-G-O, colon, 4.2.17-bionic. Okay, so that's the image. And I need to also specify some environment variables for this. And it's really easy in Kubernetes. Env, colon, return, and in this case, I do want to tab over for the dash. Don't ask me why. I don't define the YAML spec, I just use it. Name, and my Mongo name is going to, or my environment variable is going to be just like it was in Docker Swarm. Mongo underscore initdb underscore database, and then hit return and tab, and the value for this environment variable is logs, just like we were using in Docker Swarm. Then backspace and another dash and name. In this case, it's Mongo initdb underscore root underscore password or username. We'll do that one first. Username. And its value lined up with the name is admin. Then backspace once to get to the same spot. The next environment variable is name Mongo initdb underscore root underscore password in all caps, and its value is password, suitable for development. Okay, and then backspace to the same level as env and specify its ports. And this really doesn't do anything. It's for other people who have to read this file. Okay, so it's purely descriptive. Container port, and the one for Mongo is 27017. Okay? So that actually is defining a particular deployment. But we need to have access to this. And this is one of the things that makes Kubernetes a little more complex than Docker Swarm. So I hit a couple of spaces, return a couple of times, and I backspace all the way over to the left margin. And then I have to type 1, 2, 3 dashes, or hyphens if you prefer. And now I define the service that's associated with this deployment. Now I could put this in its own file and it would work just fine, but, and this is purely a matter of personal preference, when I'm defining a pod as I do here, I always put its services in the same file. And in order to make sure they work as expected, those 3 dashes have to separate things. So let's define a service, API, version, just like we did above. And in this case, it's just v1. The kind is a service with a capital S. The metadata, colon, return, tab, name, Mongo. I'm going to use the same name here as I did above in the deployment. Then return, and back, and now the spec for this service. So return, tab, it has to have a selector. Return, tab, and the name for this selector is Mongo. Then back over to the same level as selector, and we give it ports. And tab once, hit a dash and a space. The protocol for this, the network protocol, it's TCP. That's what Mongo uses. Then at the same level as protocol, give it a name, and I'll call it main-port, and that's purely descriptive. And the port in question is 27017. And the target port, so the port we're exposing to the cluster as a whole is 27017, and the target port in the container is exactly the same, 27017. So very similar to the syntax we're using in Docker Swarm, just a different way of representing that information, okay? So that is now my file. I have it, so I'll save that. Now, let's open our terminal window and make sure I'm in the project folder, and I'll type ls, and I should see that folder K8. There it is. Now, I want to deploy everything that's in that folder. So in the project folder, in other words, right beside the folder K8s, I'm going to type kubectl space apply space -f space and then the name of that folder. And that's going to apply all of the things that it finds inside of that folder that it can. So let's hit return and see what happens. So I have an error on line 25 of my YAML file. Now line 25, right here. There's a typo right there. It's actually on line 24. That should be a colon. And I'm sure you saw me type that. So I'll clear the screen, hit the up arrow, and try that again. Okay, so we now have deployed that service. That means when I type kubectl get pods, you see that I have Mongo up and running. And it has 0 out of 1 running, okay? So it seems to be trying things. But if I'll open a new terminal window by coming over here and choosing a new bash terminal. And we're going to open it inside the project folder. Okay. And from here, I can actually type minikube dashboard. And that brings up my minikube dashboard. And you can see now I have 1 deployment running, I have 1 pod running, and I have 1 replica set running. Okay, so here's Mongo under deployments and the actual name of the pod. And of course that name is generated by Kubernetes. And I have 1 replica set running. Okay, and let's go back to our terminal. And I'll switch over to the one that's actually running, not running the dashboard. And let's type kubectl get SVC for service. And as you can see, we have the Kubernetes service itself running, which is absolutely critical or nothing would work. But we also have the Mongo service up and running. Okay. Now let's try another command. So far we've used, let's just review these. Kubectl get pods. And of course that gave me the list of pods. Kubectl get service, which lists the services. Now let's try kubectl get deployments. Okay, and there is Mongo. It's now running, it's up to date, it's available, and it's been up for 2 minutes and 19 seconds. So we can't actually do anything with it right now, but it is there, it is available, and it is running. Okay, so let's move on and start defining some more pods that we can add to our Kubernetes cluster. All right, so we have 1 pod up and running. Let's do another one. But first, let's go over here in Visual Studio Code and find the extensions bit. And we're going to search for an extension called, not surprisingly, Kubernetes. Right there. Let's install that one and see what that does. It might do something useful. You never know. Okay, so I've installed that. Okay, so in theory, that's going to be better. Now, it's giving me some warnings. 1 or more containers do not have resource limits. That's okay. One of the things you can do in Kubernetes, actually in Kubernetes you have much finer grained control about your individual pods than you do for containers in Swarm. Although you can specify resource limits, how much memory should it use, how much CPU, that sort of thing. It's more or less a suggestion in Swarm. You will be ignored if you go over the limit for many cases. In Kubernetes, you can be much more specific. And I'm not going to worry about that. I'll leave that as an exercise for you if you want to apply resource limits to your containers. Our containers are all, our pods are all really resource light. They're not grabbing a lot of resources. In any case, we have that. Okay. Now, let's deploy another one. And this time we'll do RabbitMQ. So what I'm going to do is go back to my K8s folder in the project folder, and I'll create a new file called rabbit.yml. Okay, and to save some time, I'm going to copy the Mongo file and paste it in rabbit.yml. Okay, and we'll just make some changes. So the API version will stay the same. The deployment will stay the same. The metadata, the name will be rabbit. And the same thing down here for the match labels and here. And the name of the container will be rabbit as well. And the image, obviously that has to change. That's going to change to rabbit. I shall call it RabbitMQ. That's closer to what I want it to be here. Paste it there, and then we'll fix the container, the image in a minute. So copy it here, paste it here, here, and here. Now, the image, we'll use the same image we used before, RabbitMQ : 3.9-Alpine. And again, I would run Rabbit as its own separate service. Actually, just an installation of Rabbit on another server somewhere else in production. But again, this will get us going. And we don't have any environment variables to worry about, so we'll delete that. And the container port for Rabbit is 5672. Okay, so that should take care of the pod. Now let's do the service. And again, the name will be RabbitMQ. And it's important that I use RabbitMQ here because that's what I have used in my Docker Swarm file, and that's how I'm referring to it in the actual code for our microservices. So make sure you're using the same name here that you used in the URLs you specified when you connect to RabbitMQ in your Go code. The selector will be RabbitMQ. And the protocol is TCP. The port is 5672. And again, 5672. Okay, so that's done. Let's open a terminal and try deploying that. So, in the project folder, right beside the K8s folder, I'll clear the screen and type, and this time I'll specify the file, not everything in that folder. It's really easy. We say kube control, apply -f, and I want to apply K8s/rabbit.yml, and I hit return. And there, it seems to be running. So if I go back over to my dashboard, you see we have one pending, and it takes a while for Rabbit to start up, but that should start up and be available within our cluster. So we'll give it a few seconds, and hopefully that will turn green. And there it is. It's up and running. Okay, so now we have two things. So again, if I type kube control get pods, I should see it. And there it is. And if I type kube control get SVC for service, there it is. Kubernetes, Mongo, and RabbitMQ. Everything seems to be behaving exactly as it should. Okay, let's move on and deploy another service. So we have a couple of pods up and running in our cluster, and it's time to deploy another one. And I'm going to deploy the broker service this time around. But before I go too far, let's have a look over at the mongo.yml file, for example, either Mongo or Rabbit. Those squiggly lines giving me a warning were actually bothering me. So I added this section to both of the deployments that we've done so far. And it's just called resources, and it describes the lower limit and the upper limit for both memory and CPU. And I gave 64 megs of memory. When you start this service, give it at least 64 megs of memory and allow it to use 250 Ms, and you can look up that unit if you're interested, of CPU time. And the upper limit, never go beyond 128 megs or 500 Ms. Okay, so I added that here, and I added it also over here. Now, I want to deploy a broker service. So we'll do the same thing we did before. I'll go over here to the K8s folder and create a new file called broker.yml. Okay? And I'll copy, say, the Rabbit one. So I'll select all and copy my last one I created, and I'll paste it into broker and modify it as necessary. Okay? So for metadata, I'm going to call this broker-service. Okay? Because that's what I called it over here in swarm.yml. Broker-service. And it will just make things much easier. I won't have to go and modify any Go code. So I'll copy this, and I'll paste it here, and paste it here, and paste it here. And then I'll go get exactly the same image from my swarm.yml file, which is right here. So I'll copy that. Go back to the broker and paste it in where the image is specified. The resource limits should be fine. Now, do we have a container port? Let's go look at swarm.yml and see what port we're listening to. None there. We're not specifying one there. But if we go over to the broker service, the actual Go code, cmd main.go, I'm listing on port 8080. Okay, so I'll close that. And I'll go back to broker.yml, and I'll put it in here. We'll be changing this probably before we're finished, but this is a good start. And once again, down in the service section, I'm going to use the same name for consistency. Just makes things a lot easier. And my port is 8080, and my target port is 8080. Okay, I don't think anything else here has to change. So let's open our terminal window. And I'm in the project folder right beside the K8s folder. So now I should be able to type cube control, apply, -F. From the K8s folder, I want the broker file. And it created them. That's encouraging. Now over here in my other terminal, I still have the dashboard running. I ran that command minikube dashboard. So that means I can go to my web browser. And there it is. It's running already. So I have the broker, RabbitMQ, and Mongo. Perfect. Okay, as I said, we're probably going to play with this port a bit later on, but this will get us going, okay? So let's move on and deploy another service. So in the last lecture, it looked like we had everything working properly, but if you let them run for a while, you notice that you have one or two services that appear to be failing on a regular basis. And this is because I deliberately put a couple of errors. And you see it's trying to restart it right now, so it's all gone green. But if I watch it for a little bit longer, it'll go red again. This was because I have a typographical error in my deployment file, actually in all my deployment files. And I put it in there on purpose because it gives me an opportunity to show you how to diagnose and fix problems in Kubernetes. Okay? So everything appears to be working now, but it's not. And if I waited here for another 30 seconds or so, we'd have another thing failing. So let's go figure out what's going on. So back over to my IDE, and I'm going to go back to the terminal where I have been deploying things, and I'll type cube control get pods, okay? And the one that was most recently failing was actually this one, the broker service. You can see it's been restarted 3 times, and RabbitMQ has been restarted 3 times, well, 4 times and 3 times. So I'm going to copy the pod name for broker service, the entire thing, which was generated by Kubernetes. And I'll type cube control logs, and then I'll paste in that name. And you'll see here that the problem I'm having is I can't connect to RabbitMQ. There's some problem, something that is wrong there. Now, if I go back and look at the CMD API folder of the broker service and go to the main.go file, you'll see that I'm connecting to guest:guest at RabbitMQ. And that all seems to be correct. So there's something not working the way that it should be. Okay? And while we're at it, let's go look at the log file. So I'll clear the screen, and just again, I'll say cube control get pods, and I'll copy the one for RabbitMQ and see what that says. So I'll type cube control logs and paste in that pod name, the one that was generated by Kubernetes. And there's no logs there, so it seems to be doing its thing. Okay. So for right now, let's see what's going on. Let's go back over to our broker.yml file. So the problem that I see, and it's one that I put in quite deliberately just so I could give you something to talk about, is down here in the service part, the broker service. Okay, so in this one, and this is the same for all of them, under the spec, I put spec selector name broker service, and this should actually be app. So let's change that to app here. Okay, then we'll go over to Mongo, and we have the same thing here. This should be app. The selector's not working, and nothing can find anything else. And then for Rabbit, the selector should be app. Now, let's see if that takes care of it. Now, of course, this means I want to get rid of my existing deployments and start them all over again, okay, and the services. So how do I do that? How do I get rid of my deployments and services? Well, I can, at the command line, in the project folder, type cube control get deployments. And it has 3 there, okay? So I'll say cube control, delete deployments, and I'll put in the names of the deployments. Broker-service, Mongo, and RabbitMQ. Okay? So those have all been deleted. So now if I type cube control get deployments, there's nothing there. In the same way, I'll clear the screen and type cube control get SVC for services. And there they are. So I'm not going to delete the Kubernetes one, obviously, but the other 3 I can delete. Cube control, delete SVC, and I'll put in broker-service, not Kubernetes, Mongo, and RabbitMQ. And they should all be deleted, so when I clear the screen and type kubectl get service, the only one left is Kubernetes. And that's the one that I want. Now, I've made the changes to those files, okay? So I now should be able to redeploy everything by typing kubectl apply-f k8s and hit return. Okay, well, let's go back and watch this for a little while and see what's going on. So they all appear to be running. Now, I'll just go right back here and do this. Kubectl get pods. And the one that was giving me the most grief appeared to be this one. So let's copy that. And it should be waiting for RabbitMQ. I'll type kubectl logs and paste that in. And it's still backing off. And if I hit the up arrow and hit again, still backing off because RabbitMQ is not ready. So hopefully, if everything goes according to plan, it should eventually connect. Clear the screen and try it again. Still backing off. Let's try it again. Look at the log file. There, connected to RabbitMQ, starting broker service on port 8080. So that is a really useful way to look at the logs and see what's going on in individual pods. So again, how do I do that? I go kubectl get pods. I look at the pod I want to examine the logs for. I copy the name of it and type kubectl logs and paste. And everything is running there, okay? And again, to get rid of a deployment, it's kubectl get deployments. And it lists them all. And I would just type kubectl delete deployments. And then name all the deployments I want to delete. And the same thing for services, but I use SVC instead of deployments. And obviously I put the name of the service in there. So that seemed to take care of the problem for our broker service. But if you recall, we had one more crashing. And that one, let's reopen our terminal and type kubectl get pods. That one was actually, and there it is, it's crashed 6 times. So it's RabbitMQ. Now what's giving us grief there? It's almost certainly the resource limits that we set. I copied and pasted them all and I gave them relatively low ones. So probably we're going to have to increase the resource limits for Rabbit. So I'll go back and look at the dashboard. And sure enough, it's failed one more time. So let's actually clear our terminal and hide this terminal and go back to RabbitMQ and let's double its resources. So instead of saying 64 for the minimum, I'll go 128. And I'll give it an upper limit. I'll give it a really high upper limit of say 512. Okay? And again, I wouldn't be running RabbitMQ in Kubernetes in any case, but I just want to get this working. So we've made those changes. So I'll save this and I'll say, I don't actually need to stop the deployment. I can just redeploy RabbitMQ by itself. Kubectl apply-f k8s, and we're going to apply rabbit.yml, and that should reconfigure it and redeploy it. There it is. It's configured RabbitMQ, and the service is not changed. And if I go back to my dashboard now, it's giving it a try, okay? And I'll just let this run. Now, between this lecture and the next lecture, I'll wait 10 minutes or so just to make sure that those resource limits are high enough, but this should take care of it. All right, let's move on. Well, as you can see, things have stayed stable for more than 2 days. I finished this on a Friday afternoon, and here we are on Monday, and things are still running. So it sounds like we're good to go. So let's go back to our code. And this time around, let's create a deployment file for MailHog. Okay, so I'm going to open an existing one, say for Mongo, because it doesn't have huge resource requirements like RabbitMQ. And I'll create a new file in the k8s folder, a new file, which I'll call mailhog.yml. Okay, and this is in the k8s folder inside the project folder. And I'll paste in what I copied, and I'll change this, obviously. The metadata will be mailhog. And I'll copy that and paste it here and paste it here. And we'll change the name here in the container to MailHog, and we'll go get the appropriate image, which is mailhog/mailhog :latest, and that's fine. Okay, we'll leave this stuff alone. We don't have any environment variables, so we'll get rid of those. But we do have ports. And of course, these are just descriptive. So the first port is 1025, and the next one is 8025. And down here in the service, we'll change this to mailhog. And the selector will be app mailhog. And the protocol is TCP, and we have an SMTP port, which is of course port 1025. That's the one we're sending to, and the target port is 1025. And then we'll copy this entire section and paste it below for the other port. So we have two ports in this one, the SMTP port, and we have the web port for the web interface. And that's port 8025, port 8025, okay? Now, I'm not going to bother deploying this right now. We'll deploy a few of them when we're done in the next few lectures, but this is enough to get us going with Mailhog, and I believe everything is correct here. We'll find out once we deploy it. All right, let's move on and create another deployment file. So we have a deployment file for Mailhog, and let's create one for mail as well. And I'll do the same thing I did last time. I'll copy Mongo, and I'm copying this because our mail deployment does in fact have an onv section, and we can just modify this as necessary. So I'll create a new file inside of the K8s folder in the project folder called mail.yml. And I'll paste in what I just copied and go up at the top here and change this to mail-service. And again, I'm using exactly the same name as I used in my swarm file. That'll just make things simpler. And I'll change all these Mongos to mail service, and then I'll pull the appropriate image. Now, what did we use in our swarm.yml for mail? Let's find out. Mailer service. Good thing I noticed that. So I'll copy this and go back to mail.yml and change this to mailer service, or else it's just not going to work because it won't be able to find it. Mailer service, and then I'll paste in the correct image. Those resources should be fine for this. Now, what do we have for environment variables? Well, if we go back and look at swarm.yml, we have mail domain, host, and port. Let's do those first. Mail domain. And in our case, because we're using mailhog, we can just leave that as an empty string. Then we had mail host, which should be localhost. And then we had, what was the next one? Port 1025, mail port, and I'll do this one as a string because that's how it expects to find it, 1025. And then I'll just copy this to save a little bit of time. We have at least two more, so I'll copy two and paste them here and find out what the next ones are. So we're at port, encryption, username, password. So, encryption, mail encryption, that's better. Mail encryption should be set to, let's look at our swarm YML, none, none. And after encryption came username and password, both of which are empty strings. So I'll copy this, paste it here, and get the tab correct. Mail username. Mail password. And after username and password comes from name and from address. So I'll copy these two. Username should be empty, password should be empty. From name, from address, and this can be whatever I want. admin@example.com, and we'll make this one John Smith. Okay, So now we need to change our ports, but of course we do have a container port here, which we should tell people about. And again, I keep saying this, but this is purely descriptive. It's so that someone who's reading this knows what information or what ports the actual pod is listening to. So here we're going to change this to mailer service. And our selector will be mailer service. And we have port 80 going to port 80. And that should be it for that one. Okay, again, we'll deploy these when we have 2 or 3 done. So let's move on in the next lecture and take care of our next deployment file. So our next deployment file is the logger service. So let's go over to our K8s folder and create a new file called logger.yml. And again, I'll copy Mongo and select all and copy and close this and open up my logger file and paste that in. And let's go over to Swarm and find out what we called the logger service. So logger is down here. We called it logger service. Okay, and I'll copy the image right now to save some time. So back over to logger.yml, and first thing I'll do is put the image in here because it's on my clipboard. And we'll change the name from Mongo to logger-service and copy that. And paste it in all the appropriate places. As you can see, this is a little repetitive, but it's got to be done. So down here in service, we'll put that in there, and now back up to the top. Okay, what other changes do we have to make? I think the resource limits are just fine. The logger service does not have any environment variables, but it does listen on a few ports. And of course, I want to describe those. The first one is 80 when we're posting to it using JSON. Then we have port, if you'll recall, 5001 for RPC and port 50001 for gRPC. Okay? Now down here, let's change our ports. So the first one will be, say, web port, and that's port 80. And these are critical, or we're not going to be able to communicate over any of the various protocols. For posting JSON or for this one, RPC, which is port 5001, port 5001. And now we'll paste this one more time and change this one to gRPC port. And that's port 50001 and port 50001. Okay, just a note. If you look at the mail.yml that we did in the last lecture, I set mail domain. I left that set to logs, which has no effect, but we're not actually using mail domain here. But of course, if you're deploying a mailer service that's talking to, say, Spark Post or Mailgun or one of those, you do need most of these. So it's important to have them set up here just to make life easier down the road. Okay, now we have, if I recall correctly, we've done our logger, our mail, and our mail hook. And we haven't deployed any of them. So let's open our terminal and deploy these. And it's simple enough. From the project folder, we'll type qcontrol, and we're going to apply -f, and we're going to apply everything in that folder, in the K8s folder. And it will say that the existing ones are unchanged, but it will apply the new ones, if everything went according to plan. And this is an easy way to see if we have any typos as well. So let's give it a try. Everything seemed to work. And if I go back over now to my web browser, where I still have a copy of this running, we have 3 pending services. Two pending services, 1 pending service. So far, so good. It's taking its time with the last one, which is MailHog. It's probably pulling the image. Okay, everything seems to have started. But again, I'm going to come back and check this in 10 or 15 minutes just to make sure everything is still running. And I'm also going to look at this column right here, restarts, to make sure that this stays at 0. Because if I see that number going up, something's not quite right. And I'll have to go look at the log files and find out what's going on. But I expect this is going to be relatively stable. So we have a few more to deploy. We need to get our listener service, and then we need to get Postgres connected, and we'll do that one a little bit differently. We'll actually connect to a remote Postgres service, which will be simple enough. Okay, let's move on. All right, the next service we need to deploy is the listener service. So, as usual, over to the k8s folder, and we'll create a new file called listener.yml. And we'll copy, say, the logger one. We'll select all and copy, and paste it into listener. And then we go over to Swarm to make sure we have the correct name for our listener service. We called it listener service, and this is the image. So I'll copy the image. And go back to listener and paste in the image. And then we'll change this to listener service. Listener, and copy this whole thing and paste it everywhere. So we'll paste it here. I'll just copy the word listener, it's faster. Paste, paste, and all the way down here. Paste, and paste. And this just has one port, so we can delete all of this. And we can come up here and delete these. And in theory, that should work. So let's deploy it. Let's open our terminal window, and I'll clear the screen and just hit the up arrow and put /listener service or listener.yml. And that should deploy it for us. So it's created. So if I go cube control, get SPC for services, and there's the listener service. It seems to be doing its thing. Okay? So let's move on to the next step. When we'll connect Postgres to our system. And again, as I said last time, we'll actually do it a little bit differently. We'll not create a pod for Postgres. We'll do it in a way that simulates the way you might actually do it in a production environment. We'll create a Postgres service running on our local machine, and we'll connect to that remotely. So our cluster will actually connect to an external Postgres service. And that's pretty straightforward. So things are coming along. If I look at my dashboard, my Kubernetes dashboard, I have these things running. A listener service, a mailer service, Mailhog, the logger, the broker, Mongo, RabbitMQ. And conspicuous by its absence, of course, is the authentication service. And that service actually requires access to Postgres. And as I said in the last couple of lectures, I don't want to put Postgres right in this cluster. I want to simulate the way it would work in a production environment. And what I would do, typically, is to have Postgres running as some kind of remote service. I would get a managed database from DigitalOcean or something like that, or I might set up my own Postgres database on its own virtual machine up on Linode. Whatever the case may be, I want to simulate doing that this time around. And of course, that means I need to bring Postgres up on my local machine. So I'm going to go back to my Visual Studio Code. And what I'm going to do is create a new file. And I'm not going to create it in the k8s folder. And it's important that you don't. I'll create it at the root level of the project folder. I'll create a new file. And I'm just going to call it postgres.yml. Okay? And this is going to be a Docker Compose file. So what I'll do now is open Docker Compose, select all and copy, close this, and then in the new postgres.yml file, I'll paste in the contents of that file, and then I'll delete everything that's not Postgres. So all the way down to here, I can delete all of these, and I'll just bring this up, and that'll give me an instance of Postgres with the same version of the database as it was when we last ran Docker Compose. So there's Postgres. I don't need Mongo or Mailhog or RabbitMQ. I'll just delete all of those. Okay? Now that I have this file, I can bring up my terminal window, and in the project folder, so right beside the file I just created, and there it is, postgres.yml, I just type docker-compose, and this time I add -f and specify the Postgres file, then up-d. Now before you hit return, okay, go over to your Docker dashboard, which I have right here, and make sure the only thing you have running are these two Minikube instances, okay? So that's all I have running, so I'll start it up. And when I go back to my dashboard now, Docker dashboard, there it is. I have it running, okay? So now I have a Postgres I can connect to. So in the next lecture, we'll create our authentication deployment file, make sure that it points to this Postgres instance, and bring it up. So let's move on. So now that I have a local instance of Postgres up and running, let's create a deployment file for our authentication service. So I'll duplicate the one for, say, I need one that has an environment file. So perhaps I should go to Mongo. Yeah, that's got environments. So I'll select all and copy. And I'll create a new file in the K8s folder, and I'll call this one authentication.yml. And this will be our authentication microservice. And I'll paste in what I just copied. And then I'll go to my swarm file to make sure I have the same name for authentication. And I called it authentication service. So I'll copy this and go back to my authentication YML and replace all the Mongos with that. Paste, paste, paste. And down in the service section, we want the name and the app selector. Okay, now let's go back to our swarm YML. And here's the image I want, authentication service 1.0.0. I'm back to my authentication YML, and we'll find the image right here and paste that in. The resources should stay the same, but I wanted an environment variable, and I called it DSN. So I'm going to copy all of this, and we'll make a change to it. So this is the connection string that allows me to connect to the database. And of course, that's what the microservice uses to connect to Postgres. So it's called DSN, and I've just copied this. Let's go back to authentication YML, and I'll delete these ones because I only need one environment variable. And it's got to be called DSN. And I'll replace this with what I just copied. And the other change I'm going to make is I can't connect to host Postgres because that doesn't exist. Instead, Minikube gives us this name, host, try that again, host.minikube with a K dot internal. And nothing else should change. And that actually is really useful for Minikube to give that to us. And of course, if you wanted to, you could create local instances of RabbitMQ and Mongo in that same Docker Compose file we created in the last lecture, and just modify your microservices to accept an environment variable for each of those and connect to those remotely as well. And I'll leave that as an exercise for you if you want to do it. Now, other changes we have to make. Our port is only 80. And down here, our port is 80 and our target port is 80. Okay? Now with that one change, or these changes to this file, I should be able to deploy this. So let's open our terminal window and let's try deploying it. Cube control, apply -F, and I'm going to go to the K8s folder, and I'm going to get the authentication.yml service. And let's try deploying that and see what happens. So I created it. I'll go back to my Kubernetes dashboard, and it's pending. Okay, it appears to be started up. So let's go back to our terminal and look at the service itself. So cube control, get pods. And the one I want is this one, the authentication service. So I'll copy that. And I'll clear the screen and type cube control logs, paste that in there and see what happens. And it connected to Postgres. So it looks like it's up and running. That is really encouraging. Okay, let's move on in the next lecture and get a little bit further along with our Kubernetes cluster. So right now we have most of our microservices running. We have Mongo up there. We have access to an external Postgres database. We have RabbitMQ running and MailHog running. And if I type from the project folder, cube control, get SBC, we have all of these services. So everything's there except for the front end. And I have deliberately left the front end out because I want to try things and make sure that they actually work first. So what I'm going to do is try to hit the broker service in our cluster by running the front end locally. I'll just compile it and run the local version of it and hit the broker service. And if I tried that right now, it won't work. Even though it says it's listening on port 8080. The problem is that none of those ports that are listed there, with the exception of Kubernetes, which we can ignore, none of those are actually available to the outside world. Everything's inside the cluster. And what I need to do is I need to expose one service, or at least one service, from that cluster to the local network. And there's 3 different ways of doing that in Kubernetes. We could use something called a node port, or we could use something called a load balancer, and that's what I'm going to try because the logic for doing both of those is virtually identical. And the third way is the one you'll use in production, and that's called an ingress. Much like we used caddy in our swarm file as a means of getting to the services inside our swarm, our Docker swarm, we can have something called an ingress that will do the same thing for our Kubernetes cluster. So what I'm going to do right now is I'm going to first of all delete that service called broker service, and I'll replace it with another service that's actually a load balancer. Okay? So to get rid of that service, I just have to type cube control delete SVC and give it the name broker-service. So that's now deleted. And now I'm going to replace that with an entirely new service that's called a load balancer. And you do that by typing cube control expose, and we're going to call this a deployment broker-service, and the type is equal to a load balancer with a capital L and a capital B, and the port I want to hit from the outside world will be equal to 8080, and the target port is port 8080. So target dash port equals 8080. And if I hit return now, we've now exposed that service. So now if I type cube control get SVC, you'll see that the external IP for the broker service is pending. Because I've created that load balancer, I now have to type this command and leave it open. Minikube tunnel. Okay? So I execute that command, and I can't close that terminal, and I can't hit Control-C until I'm actually done with that tunnel. Okay? So I'm going to open a new tab here by clicking the plus sign, a new terminal, and I want it to be opened inside the broker service. So I'll choose broker service. Now let's go look at our broker service. Actually, I want it to be in the front end, so I'll go up one and into the front end. Sorry about that. So now I'm in the front end. So before we start our front end, let's go look at it and see what it's doing here. So we'll go to the CMD web main.go, okay? And that is listening right now on port 8081. So we'll change that 8081 just to an 80. Okay, so it'll be running on the local host. So I'm going to close this and make sure that everything else is correct on this. So that looks okay. Now I'll open the templates folder inside the front end CMD web, then the templates, then test page. And we'll change the URL at the bottom here, wherever it is. Looks like it's all of them. We'll just change this if necessary. So it's going to .broker URL. So I don't even have to change it. I just have to change what I'm handing to that actual template. So where do we do that? Let's find out. Back in main.go. Here, we're getting this broker URL. So I'm going to comment that line out. And I'll just replace it with data.broker URL is equal to http:// localhost port 8080. And that should do the trick. I'll save this because if I don't save it, then it's not going to get rid of the OS import. That's better. Let's go back and look at that test page and make sure we're just using that part of it. We are. We're actually using the broker URL and then appending the actual required bit at the end. So at this point, if everything goes according to plan, because I still have over here, I still have that tunnel running. So I'll go back to this front end and I'll type go run ./cmd/web. See what happens. So I didn't change the comment. It tells me it's listening on port 8081, but I actually, if I go to my web browser now and open a new tab and go to localhost, just like that, it brings it up. That's good. Let's try testing the broker and see what happens. And we hit the broker. Let's try authenticating. And that will actually have to hit the external database as well. And that worked as expected. So everything seems to be working just fine right now. That means that my Kubernetes cluster, once I had that tunnel exposing a load balancer to the broker service, everything is actually working exactly as I hoped it would. So the next step is to make a pod that contains our front end, add it to our cluster, and then we'll actually add an ingress, an Nginx ingress that will allow us to connect to the front end right inside the cluster. Okay, so let's get started on that in the next lecture. So now that we're reasonably certain that things are behaving as expected in our cluster, let's deploy our front end. But first, let's go back to this file, main.go, inside of the front end CMD web folder. Let's change this back to port 8081. I could leave it at 80, but I'm going to just put it back to 8081 so I don't have to rebuild the Docker image. And then down here, I'll uncomment this, get rid of this, and go back up to the imports and add OS, just to restore things as they were before. Okay, so that's done. Now, let's open our terminal, and I'll stop my front end that's running. And I don't need this terminal anymore, so I'll exit out of it. The dashboard is still running, and that's fine. I can leave that running. But let's go back to the other one where we have our tunnel open. And I'll hit Control-C to stop that tunnel. And now I'm going to want to get rid of that service. So cube control, delete, SBC, and it's called broker-service. And I have to execute this command. Otherwise, that broker service that's actually a load balancer, it'll stay there. So it's gone once I hit return. And now I'll reapply the broker service YML file just to start up the other service, the one that we had before we started the tunnel. So cube control, apply, -f, K8s, and I want the broker.yml file. And that should reapply this service. And it did. Okay, now let's close our terminals. And let's go back to the K8s folder and create a new file called front-end.yml. Okay? Now I'll just copy the broker service, select all and copy, and paste it in here. And I am going to need some environment variables, or one environment variable, and I know that Mongo has environment variables, so I'll just copy this part right here and put it at the same level as resources over here. So return, backspace, backspace, and paste. That's at the right level. And if I open my swarm.yml file, that'll give me all the information I need for this particular pod. So there's my image. Let's go back to frontend.yml. And we'll call this, find the image right here and replace that. And we'll call this front end. And we'll copy this and paste it here. And everywhere else I see broker service. And down here, there are two instances. And we'll change its ports to 8081 and 8081. And you can use 80 if you want to. And up here, the container port becomes 8081. And we change this to match whatever environment we have to have. Now the code is looking for, and this is swarm.yml, it's looking for broker URL. So let's copy broker URL and go back to frontend YML and change the name of the environment variable. And we'll change it to http://broker-service, broker service. And I'm going to use brokerservice.info, okay? Because when I try this out in a lecture or two, I'm actually going to install the Nginx ingress for Minikube, and I'm also going to install the Nginx ingress DNS add-on, and that will allow me to specify whatever I want for exposed services, okay? So we can use whatever we want there, but I'll go with broker-service.info, and that should do the trick for me. Now, I've got front end everywhere, I've got the correct ports, I have the correct environment variable, these resources should be fine. It's pointing to the right image. I think we're good, okay? So let's deploy this. So I'll open my terminal, clear the screen, and from the project folder, cube control, apply, -f, K8s/front end. And there, it created them. Okay, so assuming that works as expected, the next step is to go and set up an ingress for Minikube. And we'll take care of that in the next lecture. So now it's time to add an ingress to our Kubernetes cluster. And this is a means of accessing all of the microservices by exposing one thing, and in this case it'll be a web server called Nginx, to our local network or to the outside world. And of course, requests come into that ingress, which happens to be a web server called Nginx, and get forwarded to whatever service you need on the back end. So in essence, it's doing exactly the same thing that Caddy did in our Docker Swarm, okay? Now, you might be asking yourself, why isn't he using Caddy as an ingress to his Kubernetes cluster? And it's true that there is an experimental version of that right now as I record this, but it's not stable and it's not ready to go. So Nginx is absolutely rock solid, and that's the one I'm going to use. Now, when Caddy is finished and it's been in production for a few months, I'll give it a try, and if I'm happy with it, I'll switch to that for any Kubernetes clusters that I'm managing because I really like Caddy. But Nginx is pretty simple to set up. Now, we're doing this in Minikube, and what I need to do first is open my terminal, and I'm in the project folder, but it doesn't really matter where you are, but I'm in the project folder. I need to enable a couple of add-ons for this. So to do that, Minikube add-ons, all one word with an S at the end, enable, and I'm going to enable ingress like that, okay? And it takes a little while for this to finish. Okay, so that one's added. Now I'm going to hit the up arrow and I'm going to enable the add-on ingress-DNS for domain name server. And this is what will allow me to specify whatever I want for domain names for my local services, for the ones I'm exposing. Okay? So that's been enabled. So I will close my terminal. And the next step is to set up an ingress YML file. Now, if you go to the course resources for this lecture, you'll see a file named ingress.yml.zip. Download that, unzip it, put it inside your project folder, but not inside the K8s folder right now, okay? And let's open it up. And it looks like this. It's very simple. So it looks pretty much like a deployment file, but it has different annotations. So the way that it works, number one, API version, we're specifying that this is right from networking, from k8s.io, right from Kubernetes, version 1. Kind is an ingress. And make sure you spell it exactly like that with a capital I. I gave it a name under metadata, and I just called it my ingress. You can call it whatever you want. Just use lowercase letters and hyphens instead of spaces. Annotations needs to be exactly like that. So it takes advantage of Nginx's rewriting capability. And then the spec says, here are the rules, and I define two hosts. The first one is front-end.info. And once this is working, this is what I'll be using to connect to my front end through Nginx right into the cluster, okay? And you can see that here I'm saying the host is front-end info, and it's HTTP, and the paths are from the root. Path type is a prefix, just put that in exactly as it appears, and it goes to the back-end service named front-end, which is exactly what I called it in the deployment file, and I'm going to port number 8081, and that's the one the front end is listening on. And then because I need to expose another service, because my front end actually connects to my back end, I just call this one broker-service.info, which is the name that I chose, and it exactly matches what I put in the deployment file for the front end right here, broker-service.info. And then again, path and prefix, and this time the backend it's routing the request to is the service named broker-service listening on port 8080. Okay? So once you have that set up and make sure it matches what you have in your own deployment files, in the next lecture, we'll try deploying this and see what happens. So now that we have our ingress added to Minikube and we've created our ingress.yml file, it's time to try it out. So I'm about to do so, but as you can see right here in the dashboard, I have Minikube running and I have all my pods deployed. So we're ready to give this a try. And make sure you have Minikube running and you have all the pods deployed. So back to our terminal, and I'm inside the project folder. So I'm right beside ingress.yml, as you can see here. And to apply it, all I have to do is type kubectl apply-f ingress.yml. Okay, so that's created and it's in there now. So if I type cube control get ingress, you'll see that it's there right now. Okay, and it's up and running. And that might take a little while to become available for you. But if I keep hitting the up arrow, you'll see that I can keep relisting this as often as necessary. Now the next step is to actually edit that host file again. And again, it's different on Windows than it is on Mac or Linux, but I'm on a Mac right now, so I'll vi my etc. Try that again. Sudo vi my etc. host file. And type in my password. Try that again. There we are. So at the bottom of this, you'll see that I've added 127.0.0.1, and then I tabbed over, and I put in the two names that I have in my ingress.yml file, front-end.info and broker-service.info. And of course, that exactly matches what I have up here. I have my host, front-end-info, and down here I have the one for the broker. So once those are added, and of course you'll use it differently in Windows, but I'll put a link to a resource to edit the host file in Windows on this lecture as well. Once I have that ready to go, then the next step, and this is something you're not going to find in a lot of tutorials online, but I have to do it both on Mac and on Windows. I haven't tried it on Linux. The command is really simple. Minikube tunnel. Okay, so it's now up and running. So if I go to my web browser and open a new tab, and go to localhost, nothing shows up because I'm not going to try to hit localhost. And this is important. You can see that it's running Nginx, so it's actually up and running. If I want to hit the front end, I have to go to front or http://front-end.info. And there it is. It is up and running, and I can test the broker, and everything works exactly as expected. Now, regardless as to which particular cloud provider you're using for a Kubernetes cluster, whether it's Linode or DigitalOcean or anything like that, the steps are pretty much the same, but each one of these cloud providers has its own idiosyncrasies or its own little quirks. So for example, if I'm going to deploy this on Linode, I'm going to use an ingress YML, and I'm going to have all of my deployment files. But things are actually a little bit different for each of the cloud providers. And what I'll do in a couple of lectures is just go through the steps necessary to bring it up on Linode. I won't actually bring it up because I don't want to spend the $90 a month it's going to cost me to deploy this, but I'll show you the steps that are necessary. And regardless as to which cloud provider you're using, there are always going to be slightly different steps. But the documentation is right there, and it's pretty easy to follow. So we have this up and running now, and if I go back to my dashboard, you'll see that I only have one instance of each of these pods running. And of course, one of the great things about Kubernetes, like Docker Swarm, is you can have multiple instances of your pods. So in the next couple of lectures, we'll have a look at scaling services and updating services, and then we'll look at how you might deploy this to a given cloud provider, like Linode or DigitalOcean or Google or Amazon or any of the many ones out there that offer Kubernetes as a service. Okay? So let's move on and try scaling services. So let's have a look at how you might scale services up and down in Kubernetes. So if we go back to our dashboard, which I still have running, you'll see that I only have one instance of the logger service running. Let's say I wanted two of those. How am I going to do that? Well, there's a couple of ways. One way is to use the dashboard. I can click on the logger service under deployments. Then up here in the right-hand corner, I can click the little edit resource, the pencil icon, and that will pop up a window which shows me a version of this file that's used to deploy this. Now, Kubernetes adds a lot of information in here, but I can scroll all the way down till I find replicas, which is right here. I could change that to a 2 and click update. And that's exactly the same as this comment says of deploying the file with 2 in there. So I'm not going to bother doing it this way because I almost never do this. I'll just cancel and go back to my IDE, and I have my terminal running, and I still have the ingress tunnel running. So I'll create a new terminal, and I'll do it in the project folder. Okay. Now, if I do an ls, of the K8s folder, or a dir, to see what's in there, I have my logger.yml. Okay, so let's go edit that logger.yml and just change the number of instances or replicas, which is right here, from a 1 to a 2. Okay, and save that. And come down here, and now I just type cube control, apply -f from the K8s folder. I want the, which one did I do? Logger. Logger.yml. So it's now configured the logger service, but the logger deployment, but the service remains unchanged, as it should. So if I go back to my dashboard now and look at the workloads, so I'll click workloads up here, you'll see that I now have 2 instances of the logger service running. Now, unlike Docker Swarm, one of the things that you can do in Kubernetes, and I'm not going to go through it in this course because it's beyond the scope of the kinds of things I want to cover, you can actually configure this to automatically add resources depending upon how much traffic your site is getting. Now, what it will typically do, and again, this varies from cloud provider to cloud provider, but on Linode, for example, you can actually say, okay, I only want 1 master node and 2 worker nodes initially, so a total of 3. But if things get really busy, add another one automatically and deploy pods to it as necessary. And then when things get quieter, scale back down. So you can have upper and lower limits. And again, that varies by cloud provider, but most of them offer that functionality. So in effect, you can have auto-scaling clusters, and that's pretty useful. But in a lot of cases, unless you're getting massive traffic, the approach that I've just taken will actually meet your use case. It'll meet all of your needs, okay? So that's how you scale things. And again, if I want to bring this back down to 1 logger service, I just go back to my IDE, I change this back to a 1, and then down here, I redeploy it again. So I apply that, and it configures it, and when I go back to my dashboard, you'll see that it's dropped to 1 instance of the logger service. So, not terribly complex, okay? Now in the next lecture, we can have a look at how to update services as necessary. So the last thing I want to look at, or that last major topic I want to look at with respect to Kubernetes, is how you update services. And not surprisingly, it's almost exactly the same thing we did in the last lecture. Because in effect, when I change the number of replicas in my logger.yml file, I'm making a change to this deployment file, therefore I'm updating the service. But of course, let's say that you made some improvements to the logger service and you've built a new Docker image. Well, of course, all I have to do is to come down here and change this to the new version, whatever it is. So my new Docker image, and then I just open my terminal and I run that command to deploy the changes. And of course, you're never going to do that until you've tested it locally, right? I mean, you're going to make sure that it actually works before you deploy it to production, but literally that's all you have to do. So if I updated all of my Docker images, I could simply make the necessary changes in the YML files, in the deployment files, and then just deploy the entire folder like that. And that will apply all of the changes. And just as was the case in Docker Swarm, it does the pods one at a time. So if I have 2 instances of the logger file, it will update one, wait till it's finished, then it will update the next one, which minimizes your downtime. So anytime I'm updating something like the logger service here, for example, to a new version, let's say this became version 1.0.2, the first thing I would do is scale it to at least 2 instances, 2 replicas. And I would wait for that change to take effect, make sure that both of the new services are up or both of the replicas are up. Then I would update the image in the line 17 here to the new version, and I'd apply that change. And that would ensure that the logger doesn't go down while it's being updated. So, no magic there at all. So in the next lecture, I'll have a look at how you deploy 2 cloud services and point you to some helpful resources. Okay, let's move on. So if you've decided to go with Kubernetes as the way you're going to deploy your microservices, obviously you're going to have to put them somewhere. Now you could, if you wanted to, actually set up the necessary virtual servers in something like Linode, install Kubernetes on all the necessary servers, and do it manually. But almost nobody does that. It's a lot of work, and it's error-prone. What most people do is use a service like this. I'm logged into my Linode account right now, and I'll go over to Kubernetes, and I'll say create a cluster. And when I create a cluster, I'm actually not going to do this because they take enough of my money every month as it is. You can give it a label. You select what region you want to put it in. So I might put it in, say, Toronto or Newark, New Jersey or whatever. You put one that's close to where your actual users are going to be. And then you decide what you want to use. Now, Linode only allows dedicated CPUs, shared CPUs, and high memory CPUs. So I would say, well, I'm going to use dedicated because I need this to be as fast as possible. And as you can see, it adds up in a hurry. If I want to, for example, just go with the defaults, it's going to cost me a minimum of $60 a month. Now, one of the nice things about Linode is they actually give you the control plane server for free. And you just pay for your actual node pools. And a node pool, of course, is some kind of virtual private server. So if you want to save some money, you can go to this one, which will cost you a lot less. It's going to cost me less depending on how many nodes I have. But if I want to go with dedicated, and people deploying to Kubernetes typically are worried about performance, so they go with dedicated CPUs. Then I would deploy that. Now, back on the previous screen, you have this guide, and this is where you need to spend some time, because although the steps are very similar to what we've done with Minikube, when you're deploying to a cloud service, there's actually a little more configuration required when you start up. So this document that right here, I find in this tab. And if I go to the very top, it starts right at the beginning. It tells you what you're going to have to do, how to create the cluster, how to modify your cluster, how to delete your cluster, and next steps after deploying. For example, upgrading. And they still want you to install kube control, and they give you instructions for doing that, okay? And if you scroll on down a little bit further, you go through the steps we just went through here, create a Kubernetes cluster. And we keep going on down. And connecting to your cluster with kube control. This is where things change a little bit different. You're going to have to download a file called kubeconfig, okay? And there's instructions for doing that. It's automatically generated. So you download that. And then a little bit further on here, it tells you how to secure the file itself. And these instructions are almost exclusively for Linux, but there are similar steps and notes where necessary to point you to the Windows resources, so it can be done from Windows. And we'll keep going down here. Here's where you need to do some work, okay? So this section is entitled Persist the kubeconfig context, and you're going to want to follow all of these steps in detail, okay? And at some point, once you get past step 5, of course, you have to tell kubecontrol what are your context, what cluster are you working on? Because right now, if I go to my terminal window and I type kubecontrol config get-contexts, it shows me what context I'm currently using. And there's an asterisk right next to Minikube, so that's the one that I'm using. But once I've downloaded that configuration file from Linode and put it in the correct directory, when I type kubecontrol config get context, it'll actually show me which one I'm going to be using, or which ones are available for me to use. So of course, the next step is to say to kubecontrol, use the context, whatever name it happens to be. And I'm if I'm working on my Linode cluster, of course, I'm going to choose the name that's appropriate for my Linode cluster. So there's some steps like that. Now, much of what you're going to see in the remainder of this document is virtually identical to what we've done in this course. So deploying to a cloud service is a little complex first time around. It gets easier as you've done it more times, but it does require some extra steps. And of course, you're not going to want to deploy your cluster without SSL. So in the course resources for this lecture, I have a link to this tutorial. And it's really easy to configure TLS or SSL certificates in Kubernetes. Okay, it's relatively straightforward. And I've put a link to this resource, and I've also put a PDF version of this resource in case this link goes away at some point and then I'll do this in future. But in any case, depending on what cloud provider you're using, the steps are going to be a little bit different for each one. So it's a little bit different on DigitalOcean than it is on Linode, for example. But the resources are always there and they're relatively straightforward to follow. And once you understand how Kubernetes works, it's pretty simple to deploy it to the cloud provider of your choice.